Fact 1. The name Tyrannosaurus Rex literally means Tyrant Lizard King. The name Tyrannosaurus Rex is one of the most famous scientific names ever given to an animal, and it perfectly matches the dinosaur's terrifying reputation. The name comes from ancient Greek and Latin words. Tyrannosaurus combines the Greek words tyrannos, meaning tyrant, and sauros, meaning lizard. The word rex is Latin for king. Put together, Tyrannosaurus Rex translates directly to Tyrant Lizard King. The dinosaur received this dramatic name in 1905 from paleontologist Henry Fairfield Osborn, who was president of the American Museum of Natural History. When Osborn studied the massive fossil bones discovered in Montana, he realized the animal was unlike anything scientists had ever seen before. The skull alone was enormous, the teeth were gigantic, and the body proportions suggested an incredibly powerful predator. At the time, paleontology was still developing rapidly. New dinosaur discoveries were shocking the scientific world almost every year. But even among those discoveries, the T-Rex stood out immediately. Osborn believed the dinosaur represented one of the greatest predators to ever walk the earth, so he intentionally chose a name that sounded powerful and intimidating. Interestingly, the T-Rex was not technically a lizard at all. Dinosaurs belong to a completely different branch of reptiles than modern lizards. Birds are actually much more closely related to the T-Rex than snakes or iguanas are. However, during the early days of dinosaur research, scientists commonly used the term lizard in dinosaur names because reptiles were still poorly understood. The king part of the name also reflects how dominant the T-Rex appeared to scientists. Even today, over a century later, many people still consider the T-Rex the ultimate dinosaur predator. Few prehistoric animals have captured the public imagination in the same way. The name alone became a symbol of power, destruction, and prehistoric dominance. The popularity of the T-Rex name exploded even further through books, museums, documentaries, and movies. Films like the iconic movie Jurassic Park turned the T-Rex into a global pop culture icon. Today, even children who know almost nothing about paleontology usually recognize the name Tyrannosaurus Rex instantly. Scientific names often tell researchers important information about species, but the T-Rex name also reveals how emotional scientific discoveries can sometimes become. Osborn was not simply labeling bones. He was reacting to the overwhelming presence of the animal itself. The fossils inspired awe, fear, and fascination. Modern paleontologists still use the original name because it remains scientifically accurate and historically important. Over time, the abbreviation T-Rex became much more common in everyday conversation because it is easier to say and instantly recognizable. Still, the full scientific name continues to carry an almost legendary quality. Very few extinct animals have names that perfectly match their public image, but Tyrannosaurus Rex is one of them. Even more than 100 years after the name was first created, Tyrant Lizard King still sounds like the title of the ultimate prehistoric ruler. Fact 2. Tyrannosaurus Rex did not live throughout the entire dinosaur age. One of the biggest misconceptions people have about the Tyrannosaurus Rex is that it existed during the entire age of dinosaurs. In reality, the T-Rex appeared very late in dinosaur history. Dinosaurs ruled the Earth for over 165 million years, but Tyrannosaurus Rex only lived during the very end of that era, roughly between 68 million and 66 million years ago, during the Late Cretaceous period. That means the T-Rex existed closer in time to modern humans than it did to some of the earliest dinosaurs. To understand how surprising this is, imagine the entire age of dinosaurs as a 24-hour clock. The T-Rex would only appear during the final minutes before midnight. By the time the T-Rex arrived, countless dinosaur species had already lived, evolved, and gone extinct. Famous dinosaurs like Stegosaurus had disappeared tens of millions of years earlier. In fact, Stegosaurus lived closer to the beginning of dinosaur history than to the reign of the T-Rex. The world the T-Rex lived in also looked very different from the prehistoric landscapes people often imagine. Sea levels were much higher than today, and large inland seas divided parts of North America into separate landmasses. Forests filled with flowering plants covered much of the land. Giant reptiles, horned dinosaurs, duck-billed dinosaurs, armored dinosaurs, and enormous flying pterosaurs shared the environment with the T-Rex. Scientists discovered this timeline by studying rock layers and using radiometric dating techniques. Fossils are found in sedimentary rock formations that can be dated using nearby volcanic ash layers. This allows researchers to estimate the age of fossils with impressive accuracy. T-Rex fossils consistently appear in rock layers dating to the very end of the Cretaceous. This timing is extremely important because it means the T-Rex was one of the last non-avian dinosaurs to ever exist before the asteroid impact that caused the mass extinction event 66 million years ago. The species lived right before one of the most catastrophic moments in Earth's history. When the Chicxulub asteroid struck Earth, ecosystems collapsed worldwide, wiping out about 75% of all species on the planet, including every non-avian dinosaur. The T-Rex, therefore, represents both the peak and the end of dinosaur evolution. It existed after millions of years of predator evolution had already shaped some of the most advanced hunting dinosaurs ever seen. Many scientists believe the T-Rex was so successful because it inherited traits refined over enormous stretches of evolutionary time. Its late appearance also explains why the T-Rex looks so specialized. It had massive jaws, extremely powerful muscles, highly developed senses, and a body built specifically for dominating large prey animals of the late Cretaceous ecosystem. The T-Rex was not an early experimental predator. It was more like the final product of one of nature's longest evolutionary arms races. Fact 3. T-Rex had one of the strongest bite forces ever measured in any land animal. The Tyrannosaurus Rex possessed one of the most powerful bite forces ever estimated for a land animal in Earth's history. Scientists believe its jaws could generate between 8,000 and 12,000 pounds of force, and some newer studies suggest the bite may have been even stronger. To put that into perspective, a modern lion bites with around 650 pounds of force, while a saltwater crocodile produces roughly 3,700 pounds. The T-Rex completely surpassed both. Its skull was specially designed to deliver enormous crushing power. The head itself could grow over 5 feet long, and the jaw muscles attached to thick, reinforced bones capable of handling incredible pressure. Unlike some predators that relied mostly on slicing flesh, the T-Rex could actually crush bone. Scientists discovered evidence of this through fossilized bones from prey animals. Many fossils belonging to Triceratops and duck-billed dinosaurs show deep puncture wounds and broken bone patterns that match T-Rex teeth exactly. Some bones even contain embedded T-Rex tooth fragments. This proves the dinosaur bit down with enough force to shatter skeletons. Its teeth were also built differently from the teeth of many other predatory dinosaurs. Instead of being thin and blade-like, T-Rex teeth were thick, rounded, and banana-shaped. This design made them extremely resistant to breaking under pressure. The dinosaur could drive its teeth deep into flesh and bone without worrying about snapping them easily. Some paleontologists compare the T-Rex feeding style to modern hyenas, which crush bones to reach nutritious marrow inside. Bone marrow contains fat and nutrients that would have provided valuable energy. By crushing skeletons, the T-Rex could extract nearly every edible part from a carcass. Computer simulations of the skull show how efficiently the force spread through the dinosaur's head. Reinforced nasal bones acted almost like shock absorbers, helping the skull survive repeated massive bites. This structural strength allowed the T-Rex to attack large prey repeatedly without severely damaging its own skull. The T-Rex likely used its bite not only for feeding, but also for killing prey rapidly. A single bite could remove huge chunks of flesh, break limbs, or cause catastrophic blood loss. Large herbivores living alongside the T-Rex would have faced one of the most devastating predators in natural history. Scientists continue studying bite force, using advanced digital modeling and biomechanical analysis. Researchers scan fossils into computers and reconstruct muscles digitally to estimate how powerful the jaws were. These studies consistently place the T-Rex near the absolute top among terrestrial predators. Interestingly, some aquatic animals, like the giant prehistoric shark Megalodon, may have had stronger bites overall, but among land animals, the T-Rex remains one of the strongest ever discovered. Its bite force also helps explain why the T-Rex became such a successful predator during the Late Cretaceous. Strength allowed it to hunt heavily armored prey and fully exploit carcasses. Few animals could compete with a predator capable of crushing through flesh and bone with such terrifying efficiency. The T-Rex was not simply large. It was mechanically built to dominate through overwhelming force, and its bite was perhaps the clearest example of that dominance. Fact 4. The T-Rex had teeth the size of bananas. The teeth of the Tyrannosaurus Rex were among the most terrifying natural weapons ever developed by a land predator. Some of its largest teeth measured over 12 inches long, including the root, making them roughly the size of large bananas. These teeth were not designed like the thin razor blades seen in many other predatory dinosaurs. Instead, T-Rex teeth were thick, heavy, and built to withstand enormous pressure. Scientists often describe the teeth as being similar to railroad spikes because of their shape and strength. The teeth had thick enamel coatings and rounded cross-sections that prevented them from snapping easily when biting through bone. Unlike many predators that relied on slicing meat carefully, the T-Rex could simply bite down with devastating force and rip entire chunks from prey animals. The dinosaur possessed around 50 to 60 teeth at one time, although the exact number varied slightly between individuals. Different teeth also served different functions depending on where they sat in the jaw. The front teeth were shaped differently from the side teeth. Front teeth were often smaller and better suited for gripping and pulling flesh, while the massive side teeth delivered the crushing power. One of the most fascinating facts about T-Rex teeth is that they were constantly replaced throughout the dinosaur's life. If a tooth broke during feeding or hunting, another tooth slowly grew underneath it. This replacement process ensured the predator almost always maintained a deadly bite. Scientists have discovered many fossilized T-Rex teeth separated from skeletons because the animals frequently lost teeth while attacking prey or feeding. Unlike human teeth, which stop growing once adulthood is reached, dinosaur teeth continuously cycled throughout life. A damaged tooth could eventually be replaced completely by a new one. This gave predators like the T-Rex a huge survival advantage because broken teeth would not permanently weaken their ability to feed. Researchers have even found bite marks matching T-Rex teeth on fossils of other dinosaurs. In some cases, the marks healed partially before the animal died, proving the prey survived an attack temporarily. Other fossils show enormous gouges and crushed bone where the T-Rex likely killed the animal outright. The spacing between the teeth also played a major role in feeding. Large gaps allowed flesh and blood to escape while maintaining grip strength. Some scientists believe the bite functioned almost like a series of giant serrated knives combined with hydraulic crushing force. The edges of the teeth themselves contained tiny serrations similar to steak knives. These microscopic saw-like ridges helped the dinosaur tear through muscle, skin, and tendons more efficiently. Under magnification, the serrations appear extremely sharp and specialized for cutting flesh. Interestingly, T-Rex teeth were not perfectly straight. Many curved inward slightly, helping trap struggling prey once bitten. Escaping from the jaws of a T-Rex would have been extremely difficult because the teeth acted almost like hooks. Modern crocodiles also replace teeth continuously, and scientists sometimes compare crocodilian tooth replacement to what likely occurred in T-Rex. However, the scale of the T-Rex bite was vastly greater. The sheer size and strength of these teeth help explain why the T-Rex became one of the most dominant predators of the late Cretaceous world. Every aspect of the tooth structure evolved for maximum destruction. Fact 5. The T-Rex could probably smell prey from miles away. The Tyrannosaurus Rex had an extremely advanced sense of smell that may have rivaled or even exceeded many modern predators. Scientists discovered this by studying the dinosaur's skull and brain cavity. Inside the skull, researchers found enormous olfactory bulbs, which are the parts of the brain responsible for processing smells. In many animals, larger olfactory bulbs usually indicate a stronger sense of smell. The T-Rex had olfactory structures proportionally larger than many other dinosaurs, suggesting smell played a major role in survival. This powerful sense likely helped the predator track prey, locate carcasses, identify rivals, and navigate its environment. Some paleontologists believe the T-Rex could detect dead animals from extremely long distances, similar to how vultures and certain mammals locate carcasses today. The late Cretaceous environment contained dense forests, rivers, floodplains, and seasonal weather systems. Visibility was not always perfect, especially through vegetation. A powerful nose would therefore provide a huge hunting advantage. Scientists compare the T-Rex sense of smell to modern scavengers such as vultures, hyenas, and crocodiles. Some researchers even argue the T-Rex may have relied heavily on scavenging when opportunities appeared. However, having a strong sense of smell does not automatically mean an animal was only a scavenger. Modern predators like wolves, lions, sharks, and bears all possess excellent senses of smell while still actively hunting prey. The same was likely true for the T-Rex. The dinosaur may have followed scent trails left behind by injured animals. Blood, decaying flesh, and body odors could potentially travel long distances in the wind. Combined with its huge size and powerful bite, the ability to locate vulnerable animals efficiently would make the T-Rex even more dangerous. Researchers created digital scans of fossil skulls to estimate the size of the olfactory nerves. These scans consistently show the T-Rex ranking among the strongest smellers of all known non-avian dinosaurs. Some scientists believe smell may also have helped T-Rex identify members of its own species. Certain modern reptiles and mammals use scent for communication, territory marking, or mating behavior. While direct evidence for this remains limited, it is possible T-Rex behavior included chemical signaling. The nostrils themselves were positioned toward the front of the skull and were relatively large. This design likely allowed efficient airflow through the nasal passages. Inside the skull, the nasal chambers were extensive and may have helped process scents more effectively. There is also evidence suggesting the T-Rex brain was more advanced than many earlier giant predators. Although dinosaurs were not as intelligent as humans or primates, some predatory dinosaurs possessed surprisingly sophisticated sensory systems. A strong sense of smell would have been especially useful during nighttime or low visibility conditions. The T-Rex may not have relied solely on vision while hunting. Instead, it probably combined smell, hearing, and eyesight together. The more scientists study the T-Rex skull, the clearer it becomes that this animal was not just a giant reptile stumbling through prehistoric forests. It was an extremely specialized predator, equipped with highly developed sensory tools that helped it dominate its ecosystem. Fact 6. The T-Rex had surprisingly good vision. For many years, people imagined the Tyrannosaurus Rex as a slow and clumsy monster with poor eyesight. Modern science has completely changed that image. Evidence now suggests the T-Rex possessed remarkably strong vision, possibly even better than many living birds of prey. The dinosaur's eyes faced forward on the skull, giving it binocular vision. This means both eyes could focus on the same object simultaneously, allowing accurate depth perception. Humans also rely on binocular vision to judge distance. Depth perception is extremely important for predators because it helps them calculate attack timing, movement, and distance. Without it, accurately striking moving prey becomes much harder. Scientists study fossil eye sockets and skull structures to estimate how dinosaur vision worked. The T-Rex had very large eye sockets relative to skull size, indicating the eyes themselves were enormous. Large eyes generally gather more light, improving vision quality. Some estimates suggest a T-Rex eye may have been about the size of an orange or even larger. Bigger eyes often provide sharper vision because they can support more visual receptors. Researchers comparing T-Rex vision to modern animals found that its visual sharpness may have exceeded that of hawks and eagles. This would make sense for an apex predator that needed to track prey efficiently over long distances. The placement of the eyes also created a significant overlap in visual fields. This overlap improved three-dimensional perception. A charging T-Rex needed precise targeting when attacking massive prey animals such as Triceratops or Edmontosaurus. Some scientists estimate the T-Rex may have been able to identify prey several miles away under good conditions. Combined with its strong sense of smell and hearing, this would make the dinosaur an incredibly effective hunter. Its eyesight may also have worked well during low-light conditions. Large eyes can improve vision during dawn, dusk, or nighttime. This raises the possibility that T-Rex activity patterns varied throughout the day. One famous myth from movies suggested the T-Rex could only see movement. There is absolutely no scientific evidence supporting this idea. In reality, the dinosaur almost certainly could see stationary objects perfectly well. The myth became popular because of scenes in movies where characters survive by standing still. However, actual fossil evidence indicates the T-Rex possessed advanced visual capabilities. Scientists also examine the brain structure associated with visual processing. The regions connected to sight appear highly developed in T-Rex endocasts, which are internal molds of the brain cavity. Good vision would not only help with hunting, but also with navigation, avoiding obstacles, identifying rivals, and interacting socially with other T-Rexes. Many earlier depictions of dinosaurs portrayed them as unintelligent swamp reptiles. Discoveries about T-Rex vision helped scientists realize many dinosaurs were far more dynamic and specialized than previously believed. Today, the image of the T-Rex is very different from the outdated monster stereotype. Instead of a slow, blind predator, scientists now view it as a highly adapted apex hunter with advanced sensory abilities capable of dominating one of the most dangerous ecosystems in Earth's history. Fact 7. The T-Rex was one of the largest land predators ever discovered. The Tyrannosaurus Rex was one of the largest meat-eating animals ever to walk on land. Adult individuals could reach lengths of around 40 feet from nose to tail and stand about 12 to 13 feet tall at the hips. Some massive specimens may have weighed between 8 and 10 tons, making the T-Rex heavier than many modern elephants. Its enormous body size gave it a major advantage over nearly every other predator in its ecosystem. Very few animals would have been capable of challenging a fully grown adult T-Rex directly. Even other large carnivorous dinosaurs from earlier time periods often had lighter builds compared to the thick muscular structure of the T-Rex. Scientists estimate size by studying fossilized skeletons and comparing bone proportions. Some of the largest known specimens include famous fossils like Sue, Scotty, and Stan. Sue, one of the most complete T-Rex skeletons ever found, measures over 40 feet long and provides researchers with valuable information about the species. Scotty, another famous specimen discovered in Canada, may actually represent one of the heaviest T-Rexes ever identified. Its massive leg bones suggest extraordinary body mass and muscle strength. The giant size of the T-Rex was not just for intimidation. Large bodies helped predators overpower prey, survive injuries, store energy reserves, and dominate feeding opportunities. However, being huge also created challenges. An animal weighing several tons required enormous amounts of food. Scientists believe a T-Rex may have consumed hundreds of pounds of meat in a single feeding session. Large prey animals such as Triceratops and Edmontosaurus would have provided enough energy to sustain the predator. Its body was also carefully balanced. The huge tail acted as a counterweight to the massive skull, helping the dinosaur maintain stability while moving. Without the tail balancing the front heavy body, the T-Rex would struggle to walk efficiently. Despite its size, the T-Rex was not the absolute longest carnivorous dinosaur ever discovered. Dinosaurs like Spinosaurus may have grown longer overall. However, the T-Rex possessed a much more heavily built body and significantly stronger bite force. Many scientists therefore consider the T-Rex one of the most physically powerful terrestrial predators in history, rather than simply one of the longest. Its size also changed as it aged. Juvenile T-Rexes looked very different from adults. Younger individuals were slimmer, lighter, and likely faster. As they matured, their skulls expanded dramatically and their bodies became more muscular. This growth pattern may have allowed young and adult T-Rexes to hunt different types of prey, reducing competition within the species itself. The sheer scale of the T-Rex continues to amaze scientists and museum visitors alike. Standing beside a complete skeleton gives a sense of just how enormous the animal truly was. Even today, few land predators in Earth's history can rival the overwhelming physical presence of the Tyrannosaurus Rex. Fact 8. The T-Rex did not drag its tail on the ground. Older dinosaur artwork often showed the Tyrannosaurus Rex standing upright like a kangaroo while dragging its tail across the ground. Modern paleontology has proven this image was completely inaccurate. The T-Rex actually held its tail raised horizontally behind the body. The tail acted as a massive counterbalance to the heavy skull and torso. This posture allowed the dinosaur to move more efficiently and maintain balance while walking or running. Scientists realized the older posture was wrong after studying dinosaur skeletons more carefully during the 20th century. The bones of the spine and tail simply did not fit naturally into the tail-dragging position. Fossilized footprints also helped solve the mystery. Tracks left behind by large theropod dinosaurs rarely show any tail marks. If T-Rexes dragged their tails constantly, long grooves would appear behind the footprints. Instead, the tracks show the tail stayed elevated above the ground. The muscles inside the tail were extremely powerful. Large muscles attached from the tail to the legs helped drive movement. In many ways, the tail functioned almost like part of the engine powering the dinosaur's stride. Holding the tail off the ground also improved agility. A dragging tail would create friction and slow the animal down. By balancing the body horizontally, the T-Rex could distribute weight more effectively. Modern birds provide additional clues because birds evolved directly from theropod dinosaurs. Birds naturally balance their bodies horizontally over the legs, and the same basic principle applied to the T-Rex. The shift away from outdated dinosaur posture dramatically changed how scientists viewed dinosaurs overall. Earlier generations often imagined dinosaurs as sluggish swamp reptiles barely able to support themselves. The discovery that T-Rex held its body dynamically suggested dinosaurs were far more active and athletic than previously believed. Museum displays gradually changed over time as scientific understanding improved. Older skeleton mounts often required complete reconstruction to reflect the updated posture. Movies and documentaries also contributed to correcting public perception. Modern depictions almost always show the T-Rex with its body parallel to the ground and the tail stretched outward. The tail itself was enormous. Some estimates suggest it made up nearly half the animal's total length. Besides balancing the body, it likely stored large amounts of muscle tissue that powered movement. Researchers studying biomechanics use computer simulations to estimate how the tail functioned during locomotion. These studies consistently show that the horizontal posture was mechanically efficient. This discovery highlights how science constantly evolves. What people confidently believed about dinosaurs decades ago may later prove incorrect as new evidence appears. Today, the image of a tail-dragging T-Rex has become one of the most famous examples of outdated dinosaur science. The real Tyrannosaurus Rex was far more balanced, dynamic, and active than early scientists first imagined. Fact 9. Baby T-Rexes looked very different from adults. A fully grown Tyrannosaurus Rex looked dramatically different from its younger stages. Juvenile T-Rexes were not simply miniature copies of adults. Their bodies changed significantly as they grew. Young T-Rexes had slimmer bodies, longer legs relative to body size, narrower skulls, and smaller teeth. These features suggest juveniles were much faster and more agile than mature adults. As the dinosaur aged, its body transformed. The skull became deeper and heavier, the jaws strengthened, and the muscles thickened massively. Adult T-Rexes eventually developed the iconic giant head and crushing bite force that made the species famous. Scientists study growth patterns by examining fossil bones under microscopes. Dinosaur bones contain growth rings, similar to tree rings. These rings allow researchers to estimate age and growth speed. Studies show T-Rexes experienced extremely rapid growth during teenage years. Some individuals may have gained several pounds every single day during peak growth periods. This growth spurt allowed juveniles to transform from lightweight predators into gigantic apex hunters within a relatively short time. The changing body shape may have helped reduce competition between age groups. Younger T-Rexes probably hunted smaller, faster prey animals, while adults targeted massive herbivores. This strategy would allow multiple generations of T-Rexes to coexist in the same environment without constantly fighting over identical food sources. Juvenile T-Rexes may have behaved somewhat differently from adults as well. Their speed and agility suggest they relied more on pursuit hunting compared to the raw power of mature individuals. Some paleontologists compare the growth transition to how wolves and bears occupy different hunting roles during development. The discovery of juvenile T-Rex fossils helped solve several long-standing mysteries. For years, scientists believed certain smaller theropod skeletons represented entirely different dinosaur species. Later research revealed some of these fossils were actually young Tyrannosaurus Rex individuals. One example involved a dinosaur called Nanotyrannus. Some scientists still debate whether it represents a separate species or simply a juvenile T-Rex. The debate remains controversial in paleontology. Young T-Rexes also likely faced greater danger from predators and environmental threats. While adults sat near the top of the food chain, juveniles were much more vulnerable. Very few juvenile fossils survive compared to adult specimens because smaller bones preserve less often. This makes every discovery extremely valuable. Understanding how T-Rexes changed throughout life helps scientists build a more complete picture of the species. Instead of viewing the dinosaur as a static monster, researchers now see it as an animal that evolved physically and behaviorally from youth to adulthood. Fact 10. The T-Rex may have had feathers during part of its life. One of the most surprising discoveries in modern paleontology is the growing evidence connecting the Tyrannosaurus Rex to feathered dinosaurs. Although the T-Rex itself has not been found completely covered in preserved feathers, many close relatives possessed feathers or feather-like structures. This strongly suggests the T-Rex may also have had some form of feather covering, especially during early life stages. Scientists discovered feathered tyrannosaurs in Asia that were closely related to the T-Rex family. One famous example is Tyrannus, a large feathered predator that lived millions of years before the T-Rex. The existence of feathered tyrannosaurs changed how researchers viewed dinosaur skin and evolution. For decades, people imagined all giant carnivorous dinosaurs as scaly reptiles, similar to oversized crocodiles. Modern evidence now shows feathers evolved long before birds appeared. Some scientists believe young T-Rexes may have possessed fuzzy feather coverings that helped regulate body temperature. Juveniles had higher surface area relative to body mass, meaning they lost heat more easily than adults. As the dinosaurs grew larger, they may have lost much of this feathering because gigantic bodies naturally retain heat more efficiently. Large modern animals often struggle with overheating rather than staying warm. Adult T-Rexes may therefore have required less insulation. Skin impressions discovered from parts of T-Rex bodies show scales in certain areas, particularly around the tail and lower body. However, this does not completely rule out feathers elsewhere. Modern birds also possess scales on parts of their bodies while still being feathered overall. The feather debate remains active among paleontologists because complete skin preservation in giant dinosaurs is extremely rare. Scientists continue searching for better fossil evidence. Feathers on the T-Rex would not necessarily resemble the flight feathers of modern birds. Early feathers often looked more like fuzzy filaments or hair-like coverings. These primitive feathers likely evolved originally for insulation, display, or sensory purposes before eventually becoming useful for flight in bird ancestors. The connection between T-Rexes and birds is scientifically undeniable. Birds evolved directly from small theropod dinosaurs, meaning chickens, pigeons, and eagles are distant relatives of the Tyrannosaurus Rex. This relationship completely changed the public image of dinosaurs. Instead of being evolutionary dead ends, dinosaurs actually survive today in the form of modern birds. The idea of a feathered T-Rex may sound strange to people raised on older dinosaur movies, but scientific evidence increasingly points toward a more bird-like appearance than previously imagined. Whether fully feathered or only partially covered, the T-Rex was almost certainly more complex and biologically advanced than the classic reptilian monster once shown in outdated dinosaur artwork. Fact 11. The T-Rex had extremely tiny arms compared to its body. One of the strangest features of the Tyrannosaurus Rex was its unusually small arms. Despite being one of the most powerful predators in Earth's history, the T-Rex possessed forelimbs that looked absurdly tiny compared to the rest of its enormous body. Each arm measured only around 3 to 4 feet long, which seems incredibly small for an animal over 40 feet in total length. This unusual proportion has fascinated scientists for more than a century. At first glance, the arms almost appear useless. However, paleontologists now believe the limbs were far stronger and more functional than many people assume. The bones of the arms were thick and heavily muscled. Studies suggest each arm may have been capable of lifting several hundred pounds. The muscles attached to the upper arm and chest were powerful, indicating the limbs still served important purposes. Unlike many other predatory dinosaurs that had 3 fingers, the T-Rex possessed only 2 functional fingers on each hand. Each finger ended with a sharp, curved claw. Scientists continue debating exactly how the arms were used. Some researchers believe the limbs helped the dinosaur grip prey at close range during attacks. Others think the arms may have assisted the animal when standing up from resting positions. Another possibility is that the limbs played a role during mating by helping stabilize partners. One reason the arms appear so small is because the rest of the body became so massive during evolution. As the skull and jaws grew larger and more specialized for killing prey, the forelimbs may have become less important. The T-Rex increasingly relied on its gigantic head and crushing bite force instead of grasping prey with its hands. Interestingly, the small arms may even have reduced injury risk. Large predators often experience dangerous struggles with prey animals. Keeping the arms compact and close to the body may have prevented them from being broken during violent attacks. Despite their short size, the arms were not weak. Computer simulations show they could generate impressive force over short distances. The elbow joints also had limited flexibility compared to human arms. The T-Rex could not rotate its palms downward the way humans can. Instead, the palms likely faced inward toward each other. Many jokes and cartoons portray the T-Rex struggling humorously because of its tiny arms, but scientifically the limbs represented a highly specialized evolutionary adaptation rather than a mistake. The reduced arm size also helped balance the body. A predator with a giant head already carried enormous weight at the front. Shorter arms reduced unnecessary mass and improved overall balance. Some scientists compare the evolution of T-Rex arms to modern animals whose body structures became specialized over time. Evolution does not always preserve large limbs if other body parts become more useful. Today, the tiny arms remain one of the most recognizable and mysterious features of the Tyrannosaurus Rex. Even after decades of research, scientists still debate exactly how these strange limbs functioned in daily life. Fact 12. The T-Rex had an exceptionally strong sense of hearing. The Tyrannosaurus Rex likely possessed excellent hearing abilities that helped it detect prey, rivals, and environmental dangers across large distances. Scientists study dinosaur hearing by examining the inner ear structures preserved inside fossil skulls. Advanced scans of T-Rex skulls reveal long inner ear canals associated with balance and sound detection. Research suggests the T-Rex was especially sensitive to low-frequency sounds. Low-frequency noises travel farther through air and can move around obstacles more effectively than high-pitched sounds. Modern animals such as elephants and crocodiles also use low-frequency hearing for long-distance communication and environmental awareness. A strong hearing sense would provide enormous advantages for a giant predator living in dense prehistoric ecosystems. The T-Rex could potentially hear movements of large animals from far away, even if the prey remained hidden by forests or terrain. The ability to detect distant sounds may also have helped T-Rexes avoid unnecessary conflicts with one another. Scientists believe the dinosaurs' hearing range likely focused on deep rumbling sounds rather than high-pitched noises. Large animals naturally tend to produce lower-frequency vocalizations because of their body size. This means the T-Rex may have communicated using deep booming calls or vibrations that carried across the landscape. Some paleontologists compare possible T-Rex sounds to a mixture of crocodile rumbles, bird calls, and deep mammalian vocalizations. The famous roaring sounds heard in movies are mostly fictional. Real T-Rexes may have sounded very different from Hollywood portrayals. The inner ear structure also provided information about head movement and balance. Predators need stable coordination while tracking moving prey. Birds, which evolved from theropod dinosaurs, possess highly specialized hearing systems today. This evolutionary connection supports the idea that dinosaurs like the T-Rex were more sensory advanced than once believed. Researchers use computed tomography scans to create digital reconstructions of fossilized ear canals. These models allow scientists to estimate sound sensitivity and hearing frequency ranges. The T-Rex consistently appears well adapted for detecting deep environmental sounds. Good hearing would also improve survival during nighttime or poor visibility conditions. Combined with strong vision and smell, the T-Rex likely relied on multiple sensory systems simultaneously. Instead of functioning as a slow brute force hunter, the T-Rex now appears to have been an intelligent, sensory-driven predator capable of interpreting complex environmental information. The more researchers study the skull and brain anatomy, the more impressive the T-Rex becomes. Its hearing abilities represent another example of how highly evolved this predator truly was. Fact 13. T-Rex fossils have been found mostly in North America. Nearly all confirmed Tyrannosaurus Rex fossils have been discovered in western North America. During the Late Cretaceous period, this region looked very different from modern North America. A massive inland sea, called the Western Interior Seaway, split the continent into two large landmasses. The western portion, known as Laramidia, became the primary home of the T-Rex. Today, important T-Rex fossils have been uncovered in places such as Montana, South Dakota, North Dakota, Wyoming, Alberta, and Saskatchewan. These discoveries provide scientists with detailed information about the dinosaurs' anatomy, growth, behavior, and environment. Some of the most famous T-Rex specimens ever found came from the Hell Creek Formation, a fossil-rich geological region spanning several American states. The Hell Creek Formation preserves an extraordinary snapshot of life just before the asteroid impact that ended the age of non-avian dinosaurs. Besides T-Rexes, the area contains fossils of Triceratops, Edmontosaurus, Ankylosaurus, crocodiles, turtles, fish, mammals, and ancient plants. Because so many fossils appear together in the same rock layers, scientists can reconstruct entire ecosystems from the Late Cretaceous. The discovery history of the T-Rex itself began in North America during the early 20th century. Fossil hunter Barnum Brown discovered some of the first important T-Rex remains while working for the American Museum of Natural History. Brown became famous for his dinosaur expeditions and helped introduce the T-Rex to the scientific world. The dry badlands and eroded landscapes of western North America expose ancient sedimentary rocks, making fossil hunting easier than in heavily vegetated regions. Many T-Rex fossils remain buried underground, and new discoveries continue appearing even today. Scientists estimate only a tiny percentage of all T-Rexes that ever lived became fossilized. Fossilization requires extremely rare conditions. An animal must usually die in an environment where its remains are buried quickly before scavengers, weather, and bacteria destroy the bones. Even after fossilization occurs, the fossils must survive millions of years of geological activity before eventually becoming exposed near the surface. This means every T-Rex skeleton discovered is incredibly valuable scientifically. Researchers also study tiny fossil fragments, such as teeth, footprints, and bone pieces, to understand T-Rex distribution across ancient North America. Although closely related tyrannosaurs existed in Asia, the specific species Tyrannosaurus Rex itself remains strongly associated with North America. The continent therefore represents the final kingdom of one of the most iconic predators in natural history. Fact 14. The T-Rex lived alongside Triceratops. One of the most fascinating facts about the Tyrannosaurus Rex is that it actually lived at the same time as Triceratops. Many dinosaur documentaries, books, and movies show dinosaurs from completely different time periods interacting together inaccurately. However, the T-Rex and Triceratops genuinely shared the same late Cretaceous ecosystems. This means the two dinosaurs almost certainly encountered one another in real life. Triceratops was a gigantic plant-eating dinosaur, famous for its 3 facial horns and enormous neck frill. Adults could weigh several tons and possessed powerful defensive features. For the T-Rex, Triceratops represented both a dangerous challenge and a valuable food source. Scientists have discovered fossil evidence suggesting violent interactions between the two species. Some Triceratops bones contain healed bite marks matching T-Rex teeth. The healing proves the animal survived the attack temporarily. Other fossils show severe damage likely caused during fatal encounters. The relationship between predator and prey may have driven evolutionary changes in both animals over time. As Triceratops' defenses improved, predators like the T-Rex needed stronger bites and more effective hunting strategies. This type of evolutionary competition is often called an arms race. A full-grown Triceratops would not be easy prey. Its horns could seriously injure or even kill a predator during combat. The neck frill may also have protected vital muscles and blood vessels. Some scientists imagine confrontations between the two dinosaurs as prehistoric equivalents of battles between modern predators and heavily armed herbivores, such as lions attacking buffalo. The T-Rex probably targeted weaker individuals whenever possible, including juveniles, elderly animals, or sick members of herds. However, hungry predators may occasionally have attacked healthy adults despite the risks. Fossils from the Hell Creek Formation frequently contain remains of both species together, reinforcing the idea that they shared habitats extensively. The T-Rex and Triceratops therefore represent one of the most iconic predator-prey relationships in dinosaur history. Their coexistence also highlights how complex late Cretaceous ecosystems became before the extinction event. Instead of isolated species wandering separately, these animals formed interconnected food webs similar to modern ecosystems. The image of a T-Rex confronting a Triceratops is not merely fictional entertainment. It is one of the few famous dinosaur rivalries that almost certainly happened repeatedly in the ancient world. Fact 15. Scientists have found evidence of T-Rex cannibalism. One of the darker discoveries about the Tyrannosaurus Rex is the evidence suggesting it occasionally ate members of its own species. Scientists uncovered this evidence by studying fossilized T-Rex bones containing bite marks made by other T-Rexes. Some of these bite marks appear in locations consistent with feeding behavior rather than combat injuries. The marks often occur on bones containing large amounts of muscle tissue, suggesting scavenging or consumption after death. Cannibalism is not uncommon in nature today. Many modern predators, including crocodiles, sharks, bears, and large lizards, sometimes consume members of their own species. The T-Rex may therefore have behaved similarly under certain circumstances. Food competition in prehistoric ecosystems could become intense, especially during droughts, injuries, or seasonal shortages. A dead T-Rex would represent an enormous amount of meat. Predators that ignored such a food source might waste valuable energy. Scientists discovered bite marks on fossils from places like the Hell Creek Formation. The size and spacing of the marks closely matched T-Rex teeth. Since few other predators of similar size existed in the same ecosystem, the evidence strongly points toward cannibalistic feeding. This does not necessarily mean T-Rexes hunted each other regularly. Most evidence suggests scavenging rather than active predation. A T-Rex finding the carcass of another dead T-Rex may simply have taken advantage of an available meal. Modern carnivores behave similarly. For example, Komodo dragons frequently consume dead members of their own species when opportunities arise. Cannibalism also highlights how practical predators can be. Survival often matters more than social behavior in harsh natural environments. Researchers examining the fossil marks found no signs of healing, indicating the bites occurred after death. Some bones even contain repeated tooth gouges, showing extensive feeding activity. The discovery changed how scientists viewed dinosaur behavior. Earlier depictions often portrayed dinosaurs as simplistic creatures, but feeding evidence reveals complex ecological interactions. Cannibalism may also provide clues about T-Rex population density and territorial competition. Large predators require vast hunting ranges. Encounters between individuals may therefore sometimes end violently. Although disturbing, cannibalism fits naturally within the behavior patterns of many apex predators. The T-Rex was not a movie monster driven by cruelty. It was an animal surviving within a dangerous ecosystem where every source of food mattered. The fossil evidence reminds scientists that prehistoric life could be just as brutal and competitive as modern nature, if not even more so. Fact 16. The T-Rex probably reached full size in about 20 years. The Tyrannosaurus Rex grew at an astonishing rate during its lifetime. Scientists studying fossil bones discovered that the dinosaur likely reached full adult size in roughly 20 years, which is extremely fast for an animal that eventually weighed several tons. Researchers learned this by examining growth rings preserved inside fossilized bones. Much like trees develop annual growth rings, dinosaur bones also contain microscopic layers that record growth patterns over time. By counting these rings and analyzing their spacing, paleontologists can estimate how quickly a dinosaur matured. The T-Rex appears to have experienced an especially dramatic growth spurt during adolescence. Some studies suggest teenage T-Rexes gained around several pounds of body weight every single day during peak growth years. This rapid development transformed the animal from a relatively slim juvenile predator into one of the largest land carnivores in Earth's history. Before reaching maturity, younger T-Rexes probably occupied different hunting roles within the ecosystem. Their lighter bodies and longer legs suggest they could move faster and pursue smaller prey animals more effectively than adults. As they aged, their skulls widened, muscles thickened, and bite force increased enormously. By adulthood, the T-Rex became a heavily built apex predator capable of overpowering gigantic herbivores. Scientists believe growth slowed dramatically once full maturity was reached. Older adult specimens often show tighter bone growth rings, indicating reduced developmental speed later in life. Some fossils also contain evidence of injuries and diseases accumulated over many years, proving that certain individuals survived harsh conditions long after reaching adulthood. The rapid growth of the T-Rex required huge amounts of food and energy. Large prey animals living in the late Cretaceous ecosystem likely supported these growth demands. Researchers compare the growth rate of the T-Rex to modern birds rather than reptiles. Many reptiles today grow slowly over long periods, while birds develop quickly. Since birds evolved from theropod dinosaurs, this faster growth pattern supports the idea that dinosaurs were biologically more active than traditional cold-blooded reptiles. The growth process may also have involved hormonal changes similar to those seen in modern animals. Some scientists suspect teenage T-Rexes experienced behavioral changes during rapid development phases. Understanding growth rates helps researchers estimate population structures, hunting strategies, and survival patterns within dinosaur ecosystems. It also explains why juvenile and adult T-Rexes looked so different from one another. The fact that such a gigantic predator could reach full size within only a few decades highlights how efficient dinosaur biology truly was. The T-Rex was not simply large by accident. Its body evolved to grow rapidly, hunt effectively, and dominate its environment within a surprisingly short lifespan. Fact 17. The T-Rex may have been warm-blooded or somewhere in between. Scientists continue debating one of the biggest questions in dinosaur biology. Was the Tyrannosaurus Rex warm-blooded, cold-blooded, or something in between? Traditional reptiles such as crocodiles and lizards are cold-blooded, meaning their body temperature depends heavily on environmental conditions. Mammals and birds, on the other hand, are warm-blooded and generate their own body heat internally. The T-Rex may have possessed a metabolism somewhere between these two systems. Several lines of evidence suggest the T-Rex was far more active than typical modern reptiles. Its rapid growth rate, advanced senses, strong muscles, and active hunting lifestyle all point toward higher metabolic activity. Bone structure studies also indicate fast growth and high oxygen demands. Some scientists believe the T-Rex may have maintained relatively stable body temperatures through a process called mesothermy. Mesothermic animals produce some internal heat, but not at the same constant levels as mammals or birds. Large body size itself also helps retain heat. Gigantic animals cool down and warm up more slowly because of their volume. This phenomenon, sometimes called gigantothermy, may have helped adult T-Rexes maintain stable temperatures even if they were not fully warm-blooded. Modern leatherback sea turtles and large tuna fish show somewhat similar temperature regulation strategies. Researchers studying oxygen isotopes preserved in fossil bones found temperature patterns consistent with stable internal heat. The discovery of feathers in close tyrannosaur relatives further supports the possibility of elevated metabolism. Feathers are often associated with insulation, which becomes more useful in animals generating body heat internally. The T-Rex also likely needed substantial energy to support its enormous muscles and active predatory behavior. A purely cold-blooded metabolism may struggle to sustain such activity levels efficiently. However, some scientists argue fully warm-blooded metabolism in an animal that massive would require enormous food intake. Maintaining body heat for several tons of muscle could become energetically expensive. The truth may therefore involve a unique metabolic system, unlike anything alive today. Dinosaurs existed for over 160 million years and evolved into many specialized forms. It is entirely possible they developed biological systems not perfectly matching modern categories. Birds, the direct descendants of theropod dinosaurs, are fully warm-blooded today. This evolutionary relationship strengthens the argument that at least some dinosaur groups possessed elevated metabolisms. The debate remains one of the most exciting topics in paleontology because it affects how scientists interpret dinosaur behavior, movement, growth, and ecology. Whether warm-blooded or not, the T-Rex clearly functioned as a highly active predator rather than a sluggish reptile basking lazily in the sun. Fact 18. The T-Rex lived in a world filled with flowering plants. Many people imagine the world of the Tyrannosaurus Rex as a dark jungle, filled mostly with giant ferns and primitive plants. While ferns certainly existed, the Late Cretaceous environment actually contained many flowering plants surprisingly similar to those seen today. Flowering plants, called angiosperms, had already spread widely across the planet by the time the T-Rex appeared. This means the dinosaur likely walked through forests containing early relatives of modern trees, shrubs, and flowering vegetation. Scientists study fossil pollen, leaves, seeds, and wood to reconstruct ancient plant life. The ecosystems of Western North America during the Late Cretaceous included rivers, floodplains, forests, swamps, and coastal environments. These habitats supported enormous numbers of herbivorous dinosaurs. Plants formed the foundation of the entire food chain. Large herbivores such as Triceratops and Edmontosaurus fed on vegetation, while predators like the T-Rex depended indirectly on plant productivity through prey populations. Some ancient flowering plants likely produced fruits and seeds eaten by small animals and dinosaurs. The spread of flowering plants may even have influenced dinosaur evolution by creating new food sources and changing habitats. The climate during the T-Rex era was generally warmer than modern Earth. There were no permanent polar ice caps, and sea levels remained much higher. Forests extended into regions that are cold today. Scientists believe seasonal weather patterns still existed, including floods, storms, and droughts. The T-Rex environment, therefore, looked far more alive and dynamic than barren prehistoric wastelands often shown in older artwork. Insects, mammals, crocodiles, turtles, birds, and flying pterosaurs all shared these ecosystems. Flowering plants also likely affected dinosaur migration patterns and feeding behavior. Herbivores followed food availability, and predators followed herbivores. The rise of flowering plants during the Cretaceous period represents one of the most important botanical revolutions in Earth's history. Even today, flowering plants dominate most terrestrial ecosystems. The T-Rex, therefore, lived during a time when modern-style plant communities were already beginning to reshape the planet. Fossilized forests from the Late Cretaceous reveal complex ecosystems with rich biodiversity. Some locations preserve tree stumps, roots, and leaf impressions in remarkable detail. Understanding prehistoric plant life helps scientists reconstruct the true world of the T-Rex more accurately. The dinosaur was not wandering through a lifeless reptilian swamp. It lived within vibrant ecosystems filled with evolving plants and animals that looked increasingly familiar compared to earlier prehistoric worlds. Fact 19. The T-Rex probably had lips covering its teeth. One of the newest and most controversial debates in paleontology involves whether the Tyrannosaurus Rex had lips. For many years, movies and artwork showed T-Rex teeth permanently exposed outside the mouth like crocodiles. However, several recent studies suggest the dinosaur may actually have possessed lip-like tissues covering the teeth when the mouth was closed. Scientists supporting the lip theory point to tooth enamel preservation. Exposed teeth dry out easily and wear differently compared to teeth protected inside the mouth. The enamel on T-Rex teeth appears more similar to animals whose teeth remain covered by soft tissue. Researchers also compare skull anatomy with modern reptiles. Crocodiles possess permanently exposed teeth because they spend large amounts of time in water, where exposed enamel remains moist. Land animals often require lips or protective tissues to prevent teeth from drying and cracking. Monitor lizards provide an interesting comparison because they possess large, sharp teeth covered by lip tissues despite being reptiles. Some paleontologists, therefore, argue the T-Rex may have looked more like a giant monitor lizard than a crocodile regarding mouth structure. Others disagree and maintain that exposed teeth remain possible. The debate continues because soft tissues rarely fossilize. Without direct preservation, scientists must rely on indirect evidence from bones and tooth surfaces. If the T-Rex had lips, its appearance would differ significantly from traditional movie depictions. The teeth would remain mostly hidden while the mouth stayed closed. This does not make the animal less frightening. In fact, concealed teeth may have made sudden attacks even more intimidating. The lip debate highlights how dinosaur appearance continues evolving as new research emerges. Even iconic species like the T-Rex still contain mysteries. Scientific understanding changes constantly when fresh evidence appears. The possibility of lips also affects feeding mechanics and mouth health. Protective tissues help maintain tooth moisture and reduce damage during daily activity. Modern animals evolved similar solutions repeatedly. Researchers continue using digital modeling, enamel analysis, and anatomical comparisons to test competing theories. Whether the T-Rex had lips or not, the debate demonstrates how paleontology remains an active science rather than a collection of finalized answers. The real Tyrannosaurus Rex may ultimately look quite different from the giant reptilian monster imagined by earlier generations. Fact 20. Some T-Rex fossils show evidence of serious injuries. Several Tyrannosaurus Rex fossils preserve evidence of severe injuries, infections, and diseases survived during life. These injuries provide remarkable insights into how dangerous prehistoric life truly was. One famous specimen named Sue contains numerous damaged bones, including broken ribs, injured vertebrae, and signs of infection. The fossil reveals that the animal survived many traumatic events over its lifetime. Scientists identified healed fractures on various T-Rex skeletons, proving some individuals recovered from injuries that would likely kill many modern animals. Large predators often face serious risks while hunting. A kick, horn strike, fall, or bite from prey could cause devastating damage. Herbivores such as Triceratops possessed dangerous defensive weapons capable of injuring attackers severely. Some T-Rex skulls also contain puncture wounds, likely caused by bites from other T-Rexes. These injuries may result from territorial disputes, mating competition, or feeding conflicts. Evidence of healing indicates the animals survived long after the injuries occurred. Researchers have discovered signs of arthritis and bone infections in certain specimens. Some fossils even show abnormal bone growth caused by disease. One specimen contains damage suggesting a major facial infection that may have affected hunting ability. Despite these hardships, the dinosaur continued living long enough for healing processes to begin. This suggests the T-Rex was physically resilient and biologically capable of recovering from serious trauma. Studying injuries also helps scientists understand dinosaur behavior. For example, repeated facial bite marks may indicate aggressive interactions between individuals. Modern predators, such as crocodiles and large cats, also accumulate scars and injuries throughout life. The fossil evidence paints a picture of the T-Rex as a living animal constantly facing environmental dangers rather than an unstoppable, invincible monster. Life at the top of the food chain often comes with enormous risks. The large body size of the T-Rex may have helped it survive injuries that smaller animals could not endure. Bone healing in dinosaurs appears surprisingly similar to healing in modern birds and reptiles. Scientists use medical imaging techniques, such as computed tomography scans, to examine internal fossil damage without destroying specimens. These technologies reveal hidden fractures and infection patterns invisible from the outside. The injuries preserved in T-Rex fossils remind researchers that prehistoric ecosystems were harsh, competitive environments. Even the mighty Tyrannosaurus Rex lived a dangerous life, filled with combat, disease, and survival struggles. Fact 21. The T-Rex had one of the largest skulls of any land predator. The skull of the Tyrannosaurus Rex was one of the most enormous and powerful heads ever evolved by a land animal. A fully grown adult T-Rex could possess a skull measuring around 5 feet in length. The skull alone was nearly as large as the body of some smaller dinosaurs. This gigantic head allowed the T-Rex to house massive jaw muscles, thick crushing teeth, and advanced sensory organs. Unlike the long, narrow skulls of some earlier predators, the T-Rex skull was deep, broad, and heavily reinforced. Scientists studying skull structure discovered that the bones were fused together tightly in ways that strengthened the entire head against enormous bite forces. The nasal bones running along the top of the snout were especially strong. These bones acted almost like shock absorbers, helping distribute stress when the dinosaur bit into prey. Large openings inside the skull reduced weight while still maintaining structural strength. Nature effectively engineered a giant, lightweight weapon capable of delivering devastating force. The skull also contained enormous attachment points for muscles. The jaw muscles connecting the skull to the lower jaw were among the strongest ever evolved in a terrestrial predator. These muscles powered the famous bone-crushing bite of the T-Rex. The placement of the eyes near the front of the skull improved depth perception, while the huge nasal chambers enhanced smell. In many ways, the skull functioned as a complete hunting system, combining sight, smell, hearing, and mechanical killing power. Researchers used digital scans to study the internal architecture of T-Rex skulls. These studies reveal intricate networks of air spaces, nerves, and reinforced bone structures. Some scientists compare the skull design to modern engineering principles because it balanced strength with efficiency so effectively. The giant head also influenced the entire body structure of the dinosaur. The massive tail evolved partly to counterbalance the heavy skull and torso. Without this balance system, walking efficiently would become extremely difficult. The skull changed dramatically throughout life as well. Juvenile T-Rexes possessed narrower and lighter skulls better suited for speed. As they matured, the skull expanded massively and became much deeper. This transformation reflected the shift from agile hunter to heavyweight apex predator. Some fossil skulls preserve evidence of injuries, infections, and bite marks from combat. These marks show the skull not only served offensive purposes but also endured violent encounters. The T-Rex skull remains one of the most recognizable fossil structures in the world today. Museum visitors often stand directly beneath mounted skulls to appreciate their overwhelming size. Even compared to other giant predators in Earth's history, the Tyrannosaurus Rex possessed one of the most specialized and mechanically powerful skulls ever evolved on land. Fact 22. The T-Rex likely needed huge territories to survive. As one of the largest predators in the late Cretaceous world, the Tyrannosaurus Rex probably required enormous territories to find enough food. Modern apex predators such as lions, tigers, wolves, and bears often control large hunting ranges. The T-Rex, being vastly larger than any of these animals, may have needed territories stretching across many miles. Large predators consume enormous amounts of energy. Even if the T-Rex did not need to eat every day, maintaining several tons of muscle required substantial food intake over time. Scientists estimate a single large herbivore carcass could provide enough meat for many days or weeks. However, prey animals were constantly moving across prehistoric landscapes. The T-Rex therefore likely traveled regularly through forests, river valleys, and floodplains, searching for opportunities. Territories may also have helped reduce conflict between adult T-Rexes. Too many giant predators competing in one area would quickly exhaust prey populations. Modern ecosystems naturally support only limited numbers of apex predators because of energy constraints. Researchers study predator-prey relationships using ecological models based on modern animals. These models suggest large carnivorous dinosaurs probably existed at relatively low population densities. This means encountering another adult T-Rex may not have happened constantly. Territorial behavior could involve scent marking, vocalizations, visual displays, or aggressive confrontations. Although direct evidence remains limited, bite injuries found on T-Rex skulls suggest adults sometimes fought one another. The vast landscapes of late Cretaceous North America provided many different habitats. Some areas contained dense vegetation, while others were more open. Seasonal flooding likely changed migration routes and prey distribution. The T-Rex may have followed herds of herbivorous dinosaurs, similarly to how modern predators track migrating prey. Juvenile T-Rexes may also have occupied different territories from adults. Since younger individuals hunted smaller prey, competition within the species could remain lower. Some scientists believe the T-Rex may have spent significant time scavenging carcasses in addition to active hunting. A large territory would improve the chances of locating dead animals as well. Powerful senses of smell and hearing would help the dinosaur monitor huge areas effectively. The exact size of a T-Rex territory remains uncertain because fossil evidence cannot record movement patterns directly. Still, nearly all evidence suggests the animal required extensive hunting grounds to survive. The image of the T-Rex ruling over massive prehistoric landscapes adds another layer to understanding just how dominant this predator truly was. Fact 23. The T-Rex existed closer in time to humans than to Stegosaurus. One of the most surprising facts about the Tyrannosaurus Rex is that it lived closer in time to modern humans than it did to the Stegosaurus. Many people assume all dinosaurs existed together at the same time, but dinosaur history actually stretched across an enormous span of time. The Stegosaurus lived during the late Jurassic period, roughly around 150 million years ago. The T-Rex appeared much later during the late Cretaceous period, around 68 to 66 million years ago. This means over 80 million years separated the two dinosaurs. By comparison, humans evolved only a few million years ago. The gap between the T-Rex and modern humans is therefore shorter than the gap between the T-Rex and Stegosaurus. To understand how vast dinosaur history truly was, imagine comparing ancient Rome to modern times. That entire period becomes tiny compared to the tens of millions of years separating different dinosaur species. Dinosaurs evolved continuously over extremely long periods. Entire groups rose, diversified, and disappeared long before the T-Rex even existed. The world of Stegosaurus looked dramatically different from the world of the T-Rex. Continents had shifted, climates changed, ecosystems transformed, and many animal groups evolved or vanished entirely. The plants, predators, and prey species living alongside Stegosaurus were completely different from those encountered by the T-Rex. This fact helps correct a major misconception created by movies and popular culture. Many fictional dinosaur stories combine species from vastly different periods together inaccurately. In reality, dinosaur evolution resembled the long-changing history of mammals today. A mammoth and a house cat both belong to mammals, but evolved in very different times and ecological roles. The same principle applied to dinosaurs. Scientists determine these timelines through radiometric dating and geological analysis. Fossils appear in specific rock layers corresponding to different periods of Earth's history. The T-Rex therefore represents one of the final chapters of non-avian dinosaur evolution rather than the center of dinosaur history overall. The realization that dinosaur timespans were so immense often surprises people more than the dinosaurs themselves. The T-Rex was separated from Stegosaurus by enough time for entire ecosystems to evolve and disappear repeatedly. This perspective makes Earth's history feel far deeper and more ancient than many people initially imagine. Fact 24. The T-Rex probably did not roar like in movies. The famous deafening roar associated with the Tyrannosaurus Rex in movies is likely scientifically inaccurate. Modern research suggests the real sounds made by the T-Rex may have been much deeper, quieter, and stranger than Hollywood portrayals. Scientists study dinosaur vocalizations by comparing them with modern relatives, such as birds and crocodiles. Since birds evolved from theropod dinosaurs and crocodiles are close reptilian relatives, both groups provide clues about ancient sound production. Large modern animals often produce low-frequency sounds. Elephants create deep rumbles capable of traveling long distances. Crocodiles also generate powerful low-booming calls. The T-Rex may have produced similar deep vibrations, rather than lion-like roars. Researchers examining the inner ear structures of T-Rex skulls found evidence suggesting sensitivity to low-frequency sound. This supports the idea that the dinosaur communicated using deep, resonant noises. Some paleontologists imagine the T-Rex sounding more like a combination of crocodile bellows, bird calls, and low mammalian rumbles. Movies popularized roaring because audiences associate loud roaring with giant predators. However, roaring itself is relatively specialized among modern animals. Many large predators communicate through growls, hisses, bellows, grunts, or low-frequency vibrations instead. The anatomy of the T-Rex throat and vocal system remains uncertain because soft tissues rarely fossilize. Scientists therefore rely heavily on comparisons with living animals. Birds today produce an incredible range of sounds despite lacking the same vocal anatomy as mammals. This means dinosaurs may have created unusual noises unlike anything humans hear in modern ecosystems. Low-frequency calls would provide advantages for communication across large territories. Such sounds travel farther and penetrate obstacles better than high-pitched noises. The T-Rex may have used vocalizations for mating, territory defense, warning displays, or communication between individuals. Some sounds might even have been felt physically as vibrations rather than heard clearly. The idea of the T-Rex producing terrifying earth-shaking rumbles may actually be more scientifically realistic than the traditional cinematic scream. Although movies exaggerated the roar for dramatic effect, the real animal was likely no less intimidating. Hearing a deep prehistoric rumble echoing across a late Cretaceous forest may have been far more frightening than a fictional Hollywood roar. Fact 25. Scientists have found fossilized T-Rex skin impressions. Although complete dinosaur skin rarely fossilizes, scientists have discovered several preserved skin impressions connected to the Tyrannosaurus Rex. These impressions provide important clues about the dinosaur's appearance and texture. The preserved skin sections mostly show scales rather than feathers. The scales appear small and pebbly in texture, somewhat similar to certain modern reptiles. Different body regions may have contained different skin patterns. Some scales were tiny, while others appeared slightly larger and more organized. The fossilized impressions came from limited parts of the body such as the tail, hips, or neck. Because complete skin coverage has never been preserved, scientists still debate how much feathering the T-Rex may have possessed overall. The skin evidence confirms at least some areas of the body remained scaly. Researchers compare these fossils to skin impressions from related dinosaurs to estimate broader appearance patterns. Modern imaging technology helps scientists analyze even faint fossil impressions in remarkable detail. Some fossils preserve microscopic textures invisible to the naked eye. Skin impressions form only under extremely rare conditions. Usually, skin decays rapidly after death. To fossilize, the body must become buried quickly in fine sediment before decomposition destroys soft tissues. The rarity of preserved skin makes every discovery highly valuable. Scientists also study how scales arranged themselves across the body. Certain scale patterns may have helped with flexibility, protection, or temperature regulation. The discovery of skin impressions changed how artists reconstruct the T-Rex. Earlier depictions often used random reptile textures without fossil evidence. Now paleontologists can create more scientifically grounded reconstructions. The combination of scales and possible feathers suggests the T-Rex appearance may have been more complex than people originally imagined. Some regions may have been scaly, while others carried filament-like coverings. Modern birds also show surprising variation in skin and feather distribution. For example, bird legs often contain scales, while the rest of the body remains feathered. The T-Rex, therefore, likely displayed a mix of features inherited from earlier dinosaur ancestors. Every new skin fossil helps refine scientific understanding of how this iconic predator truly looked. Instead of being simple giant lizards, dinosaurs increasingly appear as highly specialized animals with diverse body coverings and complex evolutionary adaptations. Fact 26. The T-Rex had massive leg muscles built for power. The legs of the Tyrannosaurus Rex were among the most powerful limbs ever evolved by a land predator. Each hind leg contained enormous muscles capable of supporting several tons of body weight, while also generating enough force for movement, balance, and hunting. The thigh muscles in particular were extremely large. Scientists studying fossil skeletons discovered massive attachment points on the bones where muscles once connected. These attachment scars allow paleontologists to reconstruct muscle size and estimate strength. The upper leg bones of the T-Rex were thick and heavily reinforced. Unlike some lighter-built predatory dinosaurs designed primarily for speed, the T-Rex legs balanced power with mobility. The dinosaur needed to support its giant skull, torso, and tail while moving through complex environments. Each step likely generated enormous force against the ground. The feet themselves were also specialized. The T-Rex walked primarily on 3 large weight-bearing toes, while a smaller toe sat higher off the ground. Thick footpads probably helped absorb shock during walking and hunting. The tail played a critical role in movement as well. Large muscles extended from the tail into the legs, helping power each stride. In many ways, the tail functioned like part of the engine driving locomotion. Scientists use biomechanical computer models to estimate how the T-Rex moved. These studies show the dinosaur likely walked with impressive stability despite its huge size. The leg bones also reveal clues about speed. Although older movies often portrayed the T-Rex sprinting at extreme speeds, modern research suggests the animal probably moved at more moderate speeds to avoid injury. A fall at high speed for such a massive predator could be catastrophic. However, moderate speed does not mean slow. Even moving faster than many modern humans would make the T-Rex extremely dangerous. The leg structure suggests endurance and power mattered more than pure sprinting ability. Juvenile T-Rexes possessed proportionally longer legs and slimmer builds, indicating younger animals may have been faster. As adults grew larger and heavier, their movement style likely shifted toward powerful, deliberate motion. Some scientists compare adult T-Rex movement to large birds such as ostriches, though on a vastly larger scale. The muscles required enormous energy and oxygen, supporting the idea that the T-Rex maintained relatively active metabolism levels. The powerful legs allowed the dinosaur to dominate prey, travel across huge territories, and survive within one of the harshest ecosystems in prehistoric history. Every fossil leg bone discovered reinforces the image of the T-Rex not as a sluggish reptile, but as a physically formidable predator built for strength and stability. Fact 27. The T-Rex was probably smarter than many other dinosaurs. The Tyrannosaurus Rex was likely more intelligent than many earlier large predatory dinosaurs. Although it obviously did not possess human-like intelligence, studies of the brain cavity suggest the T-Rex had relatively advanced sensory processing and coordination abilities. Scientists study dinosaur intelligence by examining endocasts. An endocast is a natural or digital mold of the inside of the skull, showing the approximate shape of the brain. T-Rex endocasts reveal enlarged regions connected to smell, vision, balance, and sensory integration. The brain itself was proportionally larger than the brains of many giant reptiles. Some researchers compare aspects of T-Rex intelligence to modern crocodiles and birds. Birds are especially important comparisons because they evolved directly from theropod dinosaurs. Modern birds can display surprisingly complex behaviors including problem-solving, memory, social learning, and communication. The T-Rex likely possessed advanced predator instincts, requiring coordination between multiple senses. Hunting large moving prey demands timing, spatial awareness, and environmental interpretation. The strong binocular vision of the T-Rex also suggests sophisticated visual processing. Depth perception becomes highly valuable when tracking prey or navigating difficult terrain. Some paleontologists speculate the T-Rex may have shown forms of learning behavior throughout life. Animals surviving many years often become more effective hunters through experience. Fossil evidence shows some T-Rexes lived long enough to accumulate numerous healed injuries. This suggests survival strategies beyond simple instinct alone. However, scientists remain careful not to exaggerate dinosaur intelligence. The T-Rex was still fundamentally an animal shaped by evolutionary survival rather than abstract reasoning. Its intelligence likely focused heavily on sensory interpretation, movement coordination, hunting behavior, and environmental awareness. The dinosaur may also have possessed social recognition abilities. Some evidence suggests interactions between individuals could become aggressive or competitive. Recognizing rivals, mates, or territory boundaries would provide survival advantages. The cerebellum, a brain region involved in coordination and balance, appears especially developed in theropod dinosaurs. This would help stabilize the giant body during movement and attacks. Scientists continue debating exactly how intelligent large theropods truly were. Still, the outdated image of dinosaurs as unintelligent swamp creatures has largely disappeared. The T-Rex increasingly appears as a highly adapted sensory-driven predator capable of complex environmental interaction. Its intelligence may never rival mammals such as primates or dolphins, but within the dinosaur world, the T-Rex was likely among the more advanced predators ever evolved. Fact 28. Some T-Rex fossils still contain possible soft tissue structures. One of the most astonishing discoveries in paleontology occurred when scientists found structures resembling soft tissues inside certain Tyrannosaurus Rex fossils. Traditionally, researchers believed soft tissues such as blood vessels and cells could never survive for tens of millions of years. However, discoveries made in the early 21st century challenged that assumption. Paleontologist Mary Schweitzer and her research team examined a T-Rex leg bone discovered in Montana. After carefully dissolving parts of the fossilized mineral material, they uncovered flexible structures resembling blood vessels and soft tissue fragments. The discovery shocked the scientific community. Some structures even appeared stretchy when manipulated in laboratory conditions. Researchers also identified microscopic features similar to cells. These findings remain highly controversial and scientifically important. Some scientists argue the structures represent genuine remnants of original biological tissues preserved through unusual chemical processes. Others believe the material may result from bacterial activity or mineral replacement patterns mimicking soft tissues. Further studies detected traces of proteins resembling collagen, a major structural protein found in bones and connective tissue. The possibility of preserved proteins surviving for over 60 million years transformed scientific discussions about fossil preservation. Iron released from blood during decomposition may have helped preserve tissues by slowing breakdown processes. Modern experiments show iron can stabilize biological materials under certain conditions. The discovery does not mean scientists can clone dinosaurs like in fictional movies. DNA breaks down much faster than proteins and has never been recovered intact from dinosaurs. Still, the preservation of microscopic biological structures provides extraordinary opportunities for research. Scientists may learn more about dinosaur growth, metabolism, and evolutionary relationships through biochemical analysis. The findings also strengthened evidence linking dinosaurs and birds. Some preserved protein sequences appear more similar to modern birds than to reptiles. This supports the evolutionary connection between theropod dinosaurs and birds. The soft tissue discoveries completely changed assumptions about what fossils can preserve. For generations, fossils were viewed mainly as mineralized bone shapes. Now, researchers realize microscopic biological information may sometimes survive under exceptional circumstances. The T-Rex once again proved capable of surprising science even more than a century after its discovery. Every new technological advance reveals additional secrets hidden inside these ancient bones. Fact 29. The T-Rex probably experienced seasonal changes in its environment. The world of the Tyrannosaurus Rex was not a constant tropical paradise. Although the late Cretaceous climate was generally warmer than modern Earth, seasonal changes still occurred across much of North America. Scientists studying fossil plants, growth rings, sediments, and ancient river systems found evidence of wet and dry seasons. Flooding likely occurred regularly in some regions. Rivers changed course over time, reshaping the landscape. Periods of drought may also have stressed ecosystems and affected food availability. These environmental shifts influenced both herbivores and predators. Large plant-eating dinosaurs probably moved according to seasonal vegetation patterns and water sources. Predators like the T-Rex would follow prey movements to survive. Fossilized tree rings from the late Cretaceous show seasonal growth interruptions similar to those in modern trees. This indicates changing environmental conditions throughout the year. Some regions likely experience storms, heavy rainfall, and fluctuating temperatures. The T-Rex, therefore, lived in a dynamic environment rather than an unchanging jungle. Seasonal flooding may actually help explain why so many fossils formed. Rapid burial by sediment carried during floods creates ideal conditions for fossil preservation. Many dinosaur skeletons discovered today were likely buried during catastrophic environmental events. Seasonal conditions also affected hunting opportunities. Dry seasons may concentrate prey animals near water sources, making them easier to locate. Floods could expose carcasses or trap animals in dangerous terrain. Some scientists suspect juvenile and adult T-Rexes may have adapted differently to seasonal pressures because of differing prey preferences. Researchers also study oxygen isotopes preserved in fossil bones and teeth to estimate climate conditions. These chemical signatures provide information about ancient rainfall, temperatures, and water sources. The late Cretaceous environment included coastal plains, forests, swamps, and river systems stretching across western North America. The inland sea, dividing the continent, also influenced weather patterns. Warm, humid conditions probably dominated many areas, but regional differences still existed. Understanding seasonality helps scientists reconstruct the daily life challenges faced by the T-Rex. The predator had to survive not only competition and hunting dangers, but also changing environmental conditions throughout the year. Like modern ecosystems, prehistoric environments constantly shifted over time. The T-Rex succeeded because it evolved to handle these challenges effectively. Fact 30. The T-Rex was one of the last non-avian dinosaurs before the mass extinction. The Tyrannosaurus Rex lived during the final moments of the non-avian dinosaur age. Around 66 million years ago, a massive asteroid struck Earth near what is now the Yucatan Peninsula in Mexico. This impact triggered one of the most catastrophic extinction events in Earth's history. The T-Rex existed right before this disaster occurred. Scientists discovered evidence of the impact through a worldwide geological layer rich in iridium, a rare element commonly associated with asteroids. The impact crater itself, called the Chicxulub crater, measures over 100 miles wide. The collision released unimaginable amounts of energy. Massive shockwaves, wildfires, earthquakes, and tsunamis spread across the planet. Dust, ash, and vaporized material entered the atmosphere, blocking sunlight for extended periods. Without sunlight, plants began dying. As ecosystems collapsed, herbivores starved, and predators lost prey. The extinction event eliminated around 75% of species worldwide. All non-avian dinosaurs disappeared. The T-Rex therefore represents one of the final giant dinosaur predators ever to exist. Birds survived because they belonged to a smaller branch of theropod dinosaurs capable of adapting more effectively. Small body size, flight, diverse diets, and faster reproduction may have helped birds endure conditions that killed larger animals. The exact final years of the T-Rex remain uncertain. Some individuals alive shortly before the impact may have witnessed environmental changes, such as increased volcanic activity, climate fluctuations, or ecological instability. However, the asteroid impact itself appears to have been the primary extinction trigger. Fossil records from the Hell Creek Formation preserve one of the clearest snapshots of life immediately before the catastrophe. Scientists continue studying these rock layers to understand how ecosystems changed during the extinction event. The T-Rex has therefore become symbolic not only of dinosaur dominance, but also of the sudden end of an entire prehistoric era. Its extinction marked the conclusion of more than 160 million years of non-avian dinosaur rule. After the dinosaurs disappeared, mammals expanded rapidly into ecological roles previously dominated by reptiles. Eventually, this evolutionary shift helped create the conditions leading to human evolution millions of years later. The fall of the T-Rex was therefore not just the death of a predator. It was part of one of the most important turning points in the entire history of life on Earth. Fact 31. The T-Rex had a surprisingly flexible neck. The Tyrannosaurus Rex possessed a thick, muscular neck capable of supporting one of the heaviest skulls ever evolved by a land predator. Scientists studying the vertebrae of the neck discovered that the structure combined strength with a surprising degree of flexibility. The neck needed to perform several important functions simultaneously. It had to support the giant skull, stabilize the head during movement, absorb forces generated while biting prey, and allow the dinosaur to feed effectively. Large muscle attachment points appear throughout the neck vertebrae. These attachment scars reveal the presence of extremely powerful muscles connecting the skull, shoulders, and upper torso. The T-Rex likely used neck muscles to help tear flesh from carcasses. Instead of simply biting downward, the predator may have pulled its head violently backward and sideways while feeding. This motion would allow the dinosaur to remove huge chunks of meat. Some scientists compare the feeding action to modern crocodiles performing death roll-style tearing movements, although the T-Rex probably relied more on neck strength than spinning. The neck vertebrae themselves were specially shaped to allow controlled movement without sacrificing stability. The animal could raise, lower, and rotate its head with considerable force. This flexibility also helped the T-Rex track moving prey. Predators need precise head control to maintain visual focus and coordinate attacks. The balance between the skull and neck became especially important during locomotion. Each step generated vibrations through the body, and the neck muscles helped stabilize the massive head. Researchers using computer simulations found that the neck likely functioned almost like a shock absorption system. The flexibility may also explain why the T-Rex could feed efficiently from large carcasses, without needing to reposition its entire body constantly. Instead, the dinosaur could move its head and neck dynamically while remaining relatively stable. Juvenile T-Rexes probably possessed slightly different neck proportions because their skulls were narrower and lighter. As the animal matured and the skull expanded massively, the neck muscles also became thicker and stronger. Some fossils preserve evidence of neck injuries and healed damage. These injuries may have resulted from hunting accidents, fights with rivals, or collisions during feeding. Despite these risks, the neck structure proved remarkably durable. Without such a powerful neck, the giant bite force of the T-Rex would become far less effective. The neck therefore acted as a critical link between the skull and the rest of the body. Together, the skull, jaws, and neck formed one of the most formidable predatory systems ever seen in terrestrial evolution. Fact 32. The T-Rex likely needed long periods of rest between feedings. Although the Tyrannosaurus Rex was a terrifying apex predator, it probably did not hunt constantly every single day. Like many large carnivores today, the T-Rex may have spent long periods resting between major feeding events. Large predators consume enormous amounts of energy while hunting. A failed attack could waste valuable strength and expose the animal to injury. Modern lions, crocodiles, Komodo dragons, and large snakes often eat huge meals and then rest for extended periods afterward. The T-Rex likely behaved similarly. Scientists estimate that a successful feeding session on a large herbivore could provide enough meat to sustain the predator for several days. Its powerful stomach acids probably helped digest flesh, organs, and possibly even crushed bone fragments. Resting between hunts would conserve energy. An animal weighing several tons could not afford unnecessary exhaustion. The giant body of the T-Rex also produced substantial heat. Extended activity under warm, late Cretaceous climates may therefore require periods of reduced movement. Some paleontologists believe the T-Rex alternated between active hunting, scavenging, and resting, depending on opportunity and environmental conditions. A carcass discovered through smell alone might provide food without the risks associated with attacking live prey. The dinosaur may have rested in shaded forested areas, near rivers, or within open floodplain regions. Large modern predators frequently choose locations offering visibility and access to water. The T-Rex probably required significant water intake as well, especially after feeding. Its metabolism remains debated, but regardless of whether it was fully warm-blooded or mesothermic, such a large predator likely balanced activity carefully. Fossil evidence cannot directly show resting behavior, but comparisons with modern ecosystems provide strong clues. Large predators generally maximize energy efficiency because hunting carries serious risks. The T-Rex also faced potential injuries from prey animals. Rest periods would allow healing and recovery after intense physical exertion. Some scientists speculate the dinosaur may have been more active during cooler parts of the day, such as morning or evening. Large eyes and strong senses support the possibility of flexible activity patterns. The image of the T-Rex constantly rampaging non-stop across prehistoric landscapes comes mostly from movies. Real predators spend much of their lives conserving energy. The true Tyrannosaurus Rex was likely a calculated opportunistic hunter-balancing movement, feeding, and recovery within a dangerous ecosystem. Fact 33. The T-Rex shared its world with giant flying pterosaurs. The Tyrannosaurus Rex did not rule the skies. During the Late Cretaceous, enormous flying reptiles called pterosaurs soared above the same ecosystems inhabited by the T-Rex. Some of these pterosaurs were absolutely gigantic. One famous example is Quetzalcoatlus, which may have possessed a wingspan comparable to a small airplane. Although pterosaurs are often grouped with dinosaurs in popular culture, they were actually separate reptiles closely related to dinosaurs. They evolved flight independently long before birds became dominant. The skies above the T-Rex world therefore contained massive aerial predators and scavengers. Scientists believe some giant pterosaurs may have fed on small animals, fish, carrion, or even juvenile dinosaurs. Large carcasses left behind by predators like the T.Rex would attract scavengers from both land and air. Pterosaurs may have circled over feeding sites similarly to modern vultures. The interaction between giant flying reptiles and giant terrestrial predators created complex ecosystems. Some pterosaurs walked efficiently on land, using all four limbs. This means a T.Rex could potentially encounter them directly on the ground. The Late Cretaceous world therefore contained multiple types of giant reptiles occupying different ecological roles. Birds also already existed alongside the T.Rex. Small feathered birds likely flew through forests and wetlands, while giant pterosaurs dominated open skies. The presence of these flying animals made prehistoric ecosystems feel far more alive and diverse than many people imagine. Fossils of pterosaurs are rarer than dinosaur fossils because their bones were thin and fragile. Still, enough evidence exists to reconstruct much of their anatomy and behavior. Some pterosaurs possessed long, toothless beaks, while others retained sharp teeth. Their enormous wings allowed efficient gliding over huge distances. The T.Rex therefore lived in a world where giant reptiles existed not only on land, but also in the air. The combination of giant predators, massive herbivores, flying reptiles, birds, crocodiles, mammals, and evolving plants created one of the richest ecosystems in prehistoric history. The T.Rex may have dominated the ground, but the skies above belonged to entirely different giants. Fact 34. The T.Rex had excellent balance despite its huge size. At first glance, the Tyrannosaurus Rex appears dangerously front-heavy because of its massive skull. However, the dinosaur actually possessed remarkably effective balance systems, allowing it to move with stability despite weighing several tons. The enormous tail played one of the most important balancing roles. Stretching behind the body, the tail acted as a counterweight to the heavy head and torso. Without this balancing mechanism, the dinosaur would struggle to walk efficiently. Scientists studying skeletal proportions discovered the center of gravity sat close to the hips. This positioning allowed the legs to support body weight more effectively. The tail also contained huge muscles connected to the legs. These muscles help generate movement while stabilizing the body. The inner ear structure of the T.Rex provides additional evidence for advanced balance abilities. The semicircular canals inside the skull, which help control balance and head coordination, appear highly developed. Predators require precise balance during movement, turning, and attacking. Even slight instability could become dangerous for an animal of such enormous size. Researchers using biomechanical models found the T.Rex likely moved with controlled, deliberate motion rather than clumsy stumbling. The hips and leg joints aligned in ways that distributed weight efficiently. The feet also helped stabilize movement. Wide, powerful toes spread body mass across the ground and reduced pressure during walking. Modern birds provide useful comparisons because they inherited many balance-related anatomical features from theropod dinosaur ancestors. Large birds today maintain impressive stability despite balancing on two legs. The T.Rex represented an extreme version of this same evolutionary design. Balance became especially important during feeding. The predator often used violent head motions while tearing flesh. Strong legs and tail muscles prevented the body from losing stability during these powerful actions. The ability to remain balanced also helped avoid catastrophic falls. For an animal several tons in weight, falling while running or attacking could cause severe injury. Natural selection therefore strongly favored stability and coordination. The T.Rex may not have been an agile acrobat, but it was far from the awkward monster portrayed in older media. Instead, it evolved into a surprisingly efficient, giant bipedal predator capable of supporting and controlling its enormous body with impressive mechanical precision. Fact 35. Some scientists think juvenile T.Rexes filled different predator roles. Young Tyrannosaurus Rexes looked and behaved so differently from adults that some scientists believe juveniles occupied completely separate ecological roles. Juvenile T-Rexes possessed slimmer bodies, longer legs, lighter skulls, and smaller teeth compared to adults. These features suggest they were faster and more agile. Adult T-Rexes, by contrast, became heavily built predators, specializing in raw, crushing power. Because of these differences, younger individuals may have hunted smaller, faster prey animals, while adults targeted massive herbivores. This ecological separation would reduce competition between age groups within the same species. Modern animals sometimes display similar patterns. Young crocodiles eat insects and fish, while adults consume much larger prey. Young wolves and lions also often hunt differently from experienced adults. Scientists call this type of age-related ecological separation ontogenetic niche partitioning. Essentially, the animal changes its ecological role as it grows. Fossil evidence strongly supports major body changes throughout T-Rex development. Teenage T-Rexes likely occupied an especially unique stage. During rapid growth years, they may have functioned as medium-sized pursuit predators capable of chasing prey more effectively than adults. As body mass increased, speed likely decreased, while strength and bite force increased dramatically. This transition allowed the species to exploit many different food sources throughout life. Instead of all T-Rexes competing for the same prey, juveniles and adults may have naturally divided ecological resources. The idea also helps explain how multiple T-Rexes could coexist in the same region. A young, fast hunter and a giant bone-crushing adult would not necessarily require identical prey. Some paleontologists even describe juvenile T-Rexes as ecological equivalents of completely different predator species. The changing skull shape supports this theory strongly. Juvenile skulls were narrower and better suited for slicing flesh, while adult skulls became deeper and specialized for crushing. The discovery of these developmental changes transformed scientific understanding of the species. The T-Rex was no longer viewed as a static predator, remaining identical throughout life. Instead, it evolved behaviorally and physically across different life stages. This flexibility likely contributed to the success of the species during the Late Cretaceous. The Tyrannosaurus Rex was not just one predator. Across its lifetime, it may effectively have filled multiple predatory roles within its ecosystem, before finally becoming the dominant apex hunter of prehistoric North America. Fact 36. The T-Rex could replace broken teeth repeatedly throughout life. The Tyrannosaurus Rex constantly replaced its teeth throughout its lifetime. Unlike humans, who only developed 2 sets of teeth, the T-Rex continuously grew new teeth whenever older ones broke, wore down, or fell out. This ability was extremely important because the dinosaur used its jaws with tremendous force. Its teeth frequently struck bone during feeding and hunting. Even the strongest teeth eventually cracked or loosened under such pressure. Fortunately for the T-Rex, replacement teeth developed beneath existing ones inside the jaw. As an older tooth became damaged or detached, a newer tooth slowly moved upward to take its place. Scientists discovered this process by studying fossilized jaws and isolated teeth. Some T-Rex fossils preserve replacement teeth, still growing inside the bone beneath functional teeth. This arrangement ensured the predator almost always possessed a full, deadly bite. Researchers estimate the T-Rex may have replaced individual teeth every year or two. Over an entire lifetime, a single dinosaur likely grew hundreds of teeth. The teeth themselves were extremely thick and durable. Their banana-like shape reduced the chance of snapping during feeding. However, no tooth remained indestructible forever. Biting through bone, struggling prey, and carcasses placed enormous stress on the jaws. The constant tooth replacement system therefore represented a major evolutionary advantage. Modern sharks also replace teeth continuously, although their replacement process differs significantly. Crocodiles provide a closer comparison because they too grow replacement teeth beneath existing ones. Scientists frequently discover isolated T-Rex teeth because the dinosaurs shed them regularly. Some fossilized prey bones even contain embedded broken T-Rex teeth. This provides direct evidence of violent feeding encounters. The serrated edges of the teeth also wore down over time. Fresh replacement teeth restored cutting efficiency. The ability to maintain sharp, powerful teeth likely contributed heavily to the hunting success of the species. A predator relying on bite force cannot survive long with severely damaged jaws. Researchers studying microscopic wear patterns found that T-Rex teeth endured extreme mechanical stress. The replacement system effectively solved this problem. The process also reveals how specialized the T-Rex feeding strategy truly was. Its jaws were not delicate slicing tools. They functioned as heavy-duty crushing weapons, capable of destroying flesh and bone alike. Without continuous tooth replacement, such an aggressive feeding style would quickly destroy the predator's bite capabilities. The T-Rex therefore evolved one of the most effective dental systems in prehistoric history. Fact 37. The T-Rex probably hatched from eggs similar to modern reptiles and birds. Like all known non-avian dinosaurs, the Tyrannosaurus Rex reproduced by laying eggs. Although no confirmed T-Rex egg has been discovered yet, scientists can estimate many details about its reproduction by studying related dinosaurs and fossil evidence. The eggs were likely large, oval-shaped, and protected by hard shells similar to those of birds and reptiles. A female T-Rex probably laid multiple eggs within a nest built on the ground. The nests may have been dug into soil or vegetation to help regulate temperature. Scientists discovered nesting behavior in several other theropod dinosaurs closely related to the T-Rex. These discoveries strongly suggest tyrannosaurs also cared for eggs in some way. Some paleontologists believe adult T-Rexes may have guarded nests against predators. Eggs and hatchlings would face enormous dangers in prehistoric ecosystems. Small carnivorous dinosaurs, mammals, crocodilians, and other scavengers could easily target vulnerable nests. The hatchlings themselves likely looked very different from adults. Baby T-Rexes probably emerged as lightweight, feathered predators with relatively long legs and narrow heads. Rapid growth afterward transformed them into gigantic adults. Scientists estimate hatchlings may have weighed only several pounds at birth. This means the species experienced one of the most dramatic growth transformations known among terrestrial predators. Researchers compare dinosaur egg structures to those of modern birds because birds descended directly from theropod dinosaurs. Eggshell microstructure reveals surprising similarities. Some dinosaur parents may even have displayed primitive brooding behavior. Certain smaller theropods preserved sitting on nests strongly support this possibility. Whether giant T-Rexes physically sat on nests remains uncertain because of their enormous body weight. However, they may still have protected nesting areas nearby. The exact incubation time for T-Rex eggs remains unknown. Temperature, humidity, and environmental conditions would influence development. Seasonal climates may also affect breeding periods. The discovery of dinosaur embryos from other species allows scientists to reconstruct developmental stages more accurately. Young dinosaurs often possessed proportionally larger eyes and different skull shapes than adults. The reproductive biology of the T-Rex remains one of the most mysterious areas of study because reproductive tissues fossilize very rarely. Still, evidence from related dinosaurs strongly indicates that the T-Rex life cycle began inside carefully protected eggs within late Cretaceous nesting grounds. Fact 38. The T-Rex lived alongside early mammals. Although dinosaurs dominated the late Cretaceous world, mammals already existed during the time of the Tyrannosaurus Rex. These mammals were generally small compared to dinosaurs, but they occupied many ecological roles within prehistoric ecosystems. Some resembled tiny rodents or shrew-like animals. Others climbed trees, burrowed underground, or hunted insects at night. The T-Rex therefore shared its environment with distant ancestors of the mammals that would eventually dominate Earth after the dinosaur extinction. Fossil discoveries from formations such as Hell Creek reveal diverse mammal communities living beneath the feet of giant dinosaurs. These mammals likely survived, partly because of their small size. Small animals require less food, reproduce faster, and adapt more easily to environmental changes. Many mammals probably remained nocturnal to avoid large daytime predators. Night activity would help reduce encounters with dinosaurs. Some mammals may occasionally scavenge from dinosaur carcasses left behind by predators like the T.Rex. Others fed on insects, seeds, fruits, and small animals. The spread of flowering plants during the Cretaceous created new food opportunities for mammals. Scientists study tiny fossil teeth and jaw fragments to identify ancient mammal species. Mammal bones are far rarer and more delicate than dinosaur fossils, making discoveries especially valuable. Despite their small size, mammals possessed important advantages. Many were likely warm-blooded, furry, and highly adaptable. These traits eventually helped mammals survive the extinction event that killed non-avian dinosaurs. After the asteroid impact, ecosystems collapsed. Large dinosaurs disappeared, but many smaller mammals endured. Without giant reptilian competitors dominating most ecological roles, mammals rapidly diversified afterward. Millions of years later, this evolutionary expansion eventually led to primates and humans. The coexistence of T-Rexes and mammals highlights an important reality. The world of the dinosaurs was not purely reptilian. Modern-style animal groups already existed quietly in the background. The T-Rex may unknowingly have walked above creatures whose descendants would one day inherit the planet. Fact 39. The T-Rex probably used ambush hunting at least part of the time. Scientists continue debating exactly how the Tyrannosaurus Rex hunted. One increasingly popular idea suggests the dinosaur relied heavily on ambush tactics rather than non-stop high-speed chasing. The T-Rex possessed excellent senses of smell, hearing, and vision. These abilities would help detect prey efficiently even before launching attacks. Its large body and powerful bite made close-range assaults extremely dangerous. However, maintaining long, high-speed pursuits may prove difficult for such a massive predator. Biomechanical studies suggest the T-Rex probably moved effectively at moderate speeds, but risked injury if attempting extreme sprinting. A fall while running could break bones or damage internal organs. Ambush hunting would reduce these risks. The dinosaur may have used forests, riverbanks, vegetation, and terrain to approach prey undetected. Once close enough, the T-Rex could launch a short explosive attack using overwhelming bite force. Modern predators such as crocodiles, tigers, and some large cats also prefer ambush strategies because they conserve energy. Large herbivores like Triceratops and Edmontosaurus may have traveled in groups. Targeting isolated, sick, injured, or young individuals would improve hunting success. The binocular vision of the T-Rex supports accurate depth perception during sudden attacks. Its strong neck muscles and crushing jaws made even brief contact potentially fatal. Some scientists also suspect juvenile T-Rexes may have relied more on pursuit hunting, while adults specialized in ambush attacks. The changing body structure throughout life supports this possibility. Environmental conditions likely influenced hunting methods as well. Dense vegetation and river systems create ideal ambush terrain. Open floodplains, by contrast, may favor different approaches. The T-Rex probably adapted behavior depending on prey and surroundings. Scavenging also likely supplemented hunting. A predator capable of locating carcasses through smell would not ignore free food opportunities. Most modern apex predators combine hunting with scavenging whenever possible. The true hunting behavior of the T-Rex may therefore involve multiple strategies rather than a single fixed method. The idea of an enormous predator silently approaching through prehistoric forests before attacking at close range makes the real T-Rex arguably even more terrifying than older movie depictions. Fact 40. The T-Rex became one of the most famous dinosaurs in human history. Few extinct animals have ever captured human imagination like the Tyrannosaurus Rex. Since its scientific discovery in the early 20th century, the T-Rex became one of the most recognizable prehistoric creatures on Earth. Its enormous skull, giant teeth, powerful bite, and terrifying reputation transformed it into a cultural icon. The first major T-Rex fossils were discovered by fossil hunter Barnum Brown in western North America. When scientists realized the size and power of the predator, public fascination exploded rapidly. Museums began displaying mounted skeletons, attracting huge crowds. Books, newspapers, documentaries, toys, and artwork spread the image of the T-Rex worldwide. The dinosaur eventually became deeply connected with popular culture. Movies played a massive role in building this reputation. Films, such as Jurassic Park, introduced millions of people to realistic moving depictions of the T-Rex. The famous scenes involving the roaring predator became some of the most iconic moments in movie history. Even people with little interest in paleontology usually recognize the T-Rex instantly. Children often learn its name before knowing most modern animals. The species became symbolic of prehistoric power itself. Scientists also contributed to its fame by constantly uncovering new discoveries. Each new fossil revealed additional details about behavior, anatomy, growth, senses, and evolution, and reshaped public understanding of dinosaurs overall. The dinosaur also appears frequently in video games, advertising, logos, clothing, and educational material. Few extinct creatures possess comparable global recognition. Part of the fascination comes from the combination of familiarity and alienness. The T-Rex was an actual living animal that once walked the earth, yet it seems almost mythical because of its size and power. The species also represents the dramatic ending of the dinosaur age. Living shortly before the asteroid impact that changed life on Earth, forever gives the T-Rex an additional legendary quality. More than 100 years after its discovery, scientists still continue debating important questions about its appearance, metabolism, behavior, and evolution. The Tyrannosaurus Rex, therefore, remains both a scientific subject and a cultural phenomenon. It is not simply one dinosaur among many. For millions of people around the world, the T-Rex became the ultimate symbol of prehistoric life itself. Fact 41. The T-Rex probably had excellent depth perception. The Tyrannosaurus Rex possessed forward-facing eyes that gave it strong binocular vision. Binocular vision occurs when both eyes focus on the same object simultaneously, allowing the brain to judge distance accurately. Humans rely heavily on this type of vision for tasks requiring precision, and predators benefit from it greatly during hunting. Scientists studying T-Rex skulls discovered that the positioning of the eye sockets created significant overlap between the visual fields of both eyes. This overlap likely provided impressive depth perception. Accurate distance judgment would be extremely important for a giant predator attacking moving prey. A failed strike could waste energy or expose the dinosaur to injury. The T-Rex therefore needed precise coordination between vision, movement, and bite timing. Researchers compared the visual abilities of the T-Rex with modern birds of prey. Some estimates suggest the dinosaur may have possessed visual sharpness equal to or even exceeding certain eagles and hawks. The large size of the eyes also contributed to visual performance. Large eyes collect more light, improving image quality and potentially enhancing low-light vision. The T-Rex may therefore have hunted effectively during dawn, dusk, or cloudy conditions. Strong depth perception would also help the dinosaur navigate obstacles while moving through forests and uneven terrain. The giant body required careful coordination. Falling or misjudging terrain could cause severe injuries. The brain regions associated with visual processing also appear relatively advanced in T-Rex endocasts. This suggests the dinosaur relied heavily on sight in daily life. The famous movie idea that the T-Rex could only detect movement has no scientific support. Realistically, the animal almost certainly saw stationary objects perfectly well. The myth originated mainly from fictional storytelling rather than paleontological evidence. Modern research paints a far more sophisticated picture. The T-Rex was not a blind monster crashing randomly through prehistoric landscapes. Instead, it possessed carefully evolved sensory systems optimized for predatory efficiency. Its depth perception likely helped it become one of the most successful apex predators of the late Cretaceous world. Fact 42. The T-Rex had thick reinforced bones built to handle massive stress. The bones of the Tyrannosaurus Rex were extraordinarily strong. Every movement of such a gigantic predator placed immense stress on the skeleton. The body therefore required reinforced bones capable of supporting several tons of weight while resisting impacts, muscle tension, and hunting forces. Scientists studying T-Rex fossils discovered thick bone walls and dense structural reinforcement throughout the skeleton. The leg bones, in particular, were extremely robust. The femur, or thigh bone, supported enormous pressure during walking and feeding. These bones were much thicker relative to body size than those of many earlier predatory dinosaurs. The skull bones were also heavily reinforced. Large fused sections distributed bite forces across the head, reducing the risk of fractures. The neck vertebrae contained strong attachment points for massive muscles supporting the giant skull. Even the tail vertebrae played important structural roles by balancing the body and anchoring powerful leg muscles. Researchers use engineering principles to analyze dinosaur bones. Computer models simulate how stress moved through the skeleton during walking, biting, and turning. These studies consistently show the T-Rex skeleton was optimized for strength and durability. Bone growth patterns also reveal rapid development. The dinosaur reached enormous size surprisingly quickly, meaning the skeleton had to strengthen continuously during growth. Some fossils preserve healed fractures, proving the bones could recover from serious injuries. The reinforced skeleton also helped the T-Rex withstand combat with dangerous prey. A Triceratops horn strike or violent fall could otherwise cause catastrophic damage. The body structure therefore evolved to handle extreme physical punishment. Scientists compare the weight-bearing efficiency of T-Rex bones with modern elephants and rhinoceroses. Despite walking on only 2 legs, the T-Rex maintained impressive stability and support. The skeleton balanced strength with enough flexibility for movement. If the bones became too heavy, mobility would suffer. If too light, fractures would become more likely. Natural selection refined this balance over millions of years of theropod evolution. The result was one of the most mechanically capable terrestrial skeletons ever evolved. Fact 43. The T-Rex may have used visual displays to intimidate rivals. Modern animals frequently use body posture, sounds, and visual displays to avoid unnecessary fights. Some scientists believe the Tyrannosaurus Rex may have behaved similarly. Direct combat between giant predators carries enormous risks. Even a small injury can become life-threatening. As a result, many modern animals attempt intimidation before physical fighting begins. The T-Rex possessed several features that could contribute to visual displays. Its enormous body size alone would appear intimidating. The giant skull, huge teeth, and powerful stance may have served as warning signals to rivals. The dinosaur may also have used vocalizations, head movements, or posture changes during confrontations. Some paleontologists speculate that colorful skin, scales, or feather patches may have existed in certain areas. Modern birds, which evolved from theropod dinosaurs, frequently use visual signaling during mating and territorial behavior. Although direct evidence for T-Rex coloration remains unavailable, the possibility of display structures cannot be ruled out. Scars and bite marks found on fossil skulls suggest adult T-Rexes sometimes fought one another. However, not every confrontation would necessarily end violently. Intimidation displays could help establish dominance without severe injury. The forward-facing posture of the skull and the impressive jaws may themselves function as display weapons. Even simply opening the mouth could reveal rows of giant teeth. The size difference between individuals may also influence behavior. Larger adults could dominate smaller rivals through posture and sound alone. Researchers compare potential T-Rex behavior with crocodiles, birds, and large mammals. Many apex predators rely heavily on body language. The T-Rex likely combined sensory awareness with behavioral signaling in social interactions. Although it probably was not highly social in the mammalian sense, interactions between individuals almost certainly occurred. Territory disputes, mating competition, and feeding conflicts would all create situations where intimidation behavior becomes useful. The possibility of display behavior adds additional complexity to the T-Rex image. Instead of acting purely through instinctive violence, the dinosaur may have used sophisticated behavioral strategies to manage dangerous encounters. Fact 44. The T-Rex may have been covered in different textures across its body. The skin and body covering of the Tyrannosaurus Rex were probably more complex than a single uniform texture. Fossil evidence suggests different body regions may have displayed different coverings. Some areas likely contained scales, while others may have possessed feather-like structures. Skin impressions discovered from parts of the body show pebbly reptile-like scales. However, close tyrannosaur relatives discovered in Asia preserved filament-like feathers. This means the T-Rex may have combined both features. Modern birds provide useful comparisons because they also display varied textures. Bird legs often possess scales, while the rest of the body carries feathers. The T-Rex may similarly have exhibited regional variation. Juveniles may have possessed more feathering than adults. Smaller animals lose heat faster, making insulation more important during early growth. As adult T-Rexes became gigantic, excess feathering could potentially trap too much heat. Some scientists therefore suspect mature individuals retained mostly scales with limited feather patches. Other researchers still argue feathers may have remained widespread. The exact arrangement remains uncertain because soft tissues fossilize very rarely. Coloration also remains unknown. However, scientists studying feather pigments in smaller dinosaurs discovered that some prehistoric species displayed stripes, countershading, reddish colors, and complex patterns. The T-Rex may therefore have looked more visually diverse than older green reptile depictions suggest. Camouflage could provide advantages during ambush hunting. Patterns breaking up the body outline would help conceal movement within forests and vegetation. Display coloration may also play roles in mating or intimidation. The texture variation across the body could serve different functions simultaneously. Scales provide protection and durability, while feathers help with insulation or signaling. The evolving understanding of dinosaur skin demonstrates how dramatically paleontology changed over recent decades. The classic image of dinosaurs as oversized lizards no longer matches modern evidence. Instead, species like the T-Rex increasingly appear as biologically sophisticated animals, combining traits now seen separately in birds and reptiles. Fact 45. The T-Rex probably had powerful immune defenses. The Tyrannosaurus Rex lived within a dangerous world filled with injuries, infections, parasites, and environmental hazards. To survive long enough to reach adulthood, the species likely evolved powerful immune defenses. Many fossil specimens preserve evidence of healed injuries. Broken ribs, infected jaws, damaged vertebrae, and bite wounds all appear in different T-Rex fossils. The fact that these injuries healed at all suggests strong biological recovery systems. Large predators face constant risks. A single hunting accident could expose open wounds to bacteria and parasites. Without effective immune responses, infections would quickly become fatal. Some T-Rex fossils display signs of chronic disease that the animals survived for extended periods. Researchers discovered evidence of bone infections and inflammatory conditions. The healing patterns resemble responses seen in modern vertebrates. Birds and reptiles today both possess surprisingly effective immune systems. Because the T-Rex shares evolutionary relationships with these groups, it likely inherited similarly strong biological defenses. The dinosaur's size may also help survival. Larger animals sometimes endure injuries that smaller animals could not survive. However, large body size alone cannot prevent infection. Rapid wound healing and immune response remain critical. Scientists continue studying microscopic fossil structures to understand dinosaur disease processes. Some research even examines possible parasite damage preserved in bones. The stressful lifestyle of a giant apex predator would place constant pressure on the body. Combat with prey, rival predators, and environmental dangers likely produced frequent injuries. The T-Rex therefore needed resilient physiology to survive. Its success as a species for millions of years suggests these biological systems worked effectively. The evidence of healing reminds scientists that the T-Rex was not an unstoppable machine. It was a living animal, constantly challenged by the harsh realities of prehistoric life. Its survival depended not only on strength and aggression, but also on the remarkable ability of its body to recover from damage. Fact 46. The T-Rex probably needed massive amounts of water. Like all large animals, the Tyrannosaurus Rex required regular access to water in order to survive. Its gigantic body contained enormous amounts of muscle, blood, and tissue that depended on hydration. Scientists believe the T-Rex likely spent much of its life near rivers, floodplains, lakes, and wetland environments where water remained accessible. The late Cretaceous ecosystems of western North America contained many river systems and swampy regions. These habitats supported huge herbivorous dinosaur populations, which in turn attracted predators such as the T-Rex. Modern large predators often remain closely tied to water sources. Lions, crocodiles, bears, and wolves all depend heavily on rivers and watering areas because prey animals gather there regularly. The T-Rex probably behaved similarly. Besides drinking water directly, the dinosaur also obtained moisture from prey, flesh, and blood. Carnivorous diets can provide significant hydration. However, an animal weighing several tons would still likely need regular drinking opportunities. The exact amount of water consumed remains unknown. Scientists estimate needs indirectly by comparing the T-Rex with modern reptiles, birds, and large mammals. If the T-Rex possessed elevated metabolism levels, its water demands may have been especially high. Warm, late Cretaceous climates could increase dehydration risks as well. Rivers and wetlands also created hunting opportunities. Herbivores approaching water became more predictable and vulnerable. Flooding environments may additionally explain why so many dinosaur fossils formed in these regions. Rapid burial by river sediments preserves skeletons effectively. Researchers studying fossil sediments discovered evidence of seasonal flooding, muddy floodplains, and shifting river channels. The T-Rex therefore lived in dynamic watery landscapes rather than dry, barren deserts. Some paleontologists suspect the dinosaur could swim if necessary. Large modern animals such as elephants, bears, and even some reptiles swim surprisingly well. Although no direct evidence proves T-Rex swimming behavior, crossing rivers would likely become unavoidable within its environment. The relationship between predators and water shaped prehistoric ecosystems just as it shapes ecosystems today. The T-Rex was not merely a giant hunter wandering randomly through forests. It was part of an interconnected landscape where water influenced movement, feeding, migration, and survival. Fact 47. The T-Rex had thick, powerful feet designed to support extreme weight. The feet of the Tyrannosaurus Rex were specially adapted to support one of the heaviest predators ever to walk on two legs. Each step carried several tons of body weight. Without strong feet and toes, movement would become unstable and dangerous. The T-Rex walked primarily on three large forward-facing toes. These toes spread weight efficiently across the ground and provided balance during walking. A smaller fourth toe sat higher and likely contributed little direct support. The toes ended in thick, curved claws. Unlike the giant killing claws of some smaller theropod dinosaurs, T-Rex foot claws mainly helped with traction and stability. The feet themselves probably contained thick, soft tissue pads, similar to those found in modern birds and large mammals. These pads would absorb shock and reduce stress on bones and joints. Scientists study fossilized footprints to understand foot structure and walking behavior. Large theropod footprints show wide, stable impressions, consistent with powerful weight-bearing movement. The feet also reveal clues about speed. An animal carrying extreme mass must distribute force carefully to avoid injuries. The T-Rex likely moved with controlled, deliberate steps rather than reckless sprinting. Researchers compare the feet of theropod dinosaurs with modern birds because birds inherited many foot structures from dinosaur ancestors. Large ground birds, such as ostriches, demonstrate how effective two-legged movement can remain even in relatively large animals. The T-Rex represented a gigantic version of the same evolutionary principles. The feet also played important roles during feeding. A feeding T-Rex tearing flesh violently needed stable footing to maintain balance. Strong toes and muscular legs prevented slipping during these actions. Some fossils preserve evidence of stress injuries in foot bones. This indicates the feet endured tremendous physical pressure throughout life. The ground itself may influence movement as well. Muddy floodplains, forests, riverbanks, and wet terrain all create different walking challenges. The T-Rex feet evolved to handle these changing environments effectively. The enormous predator depended completely on its lower limbs for survival. Every hunt, territorial movement, and feeding event required reliable support. The structure of the feet therefore reveals how carefully evolution shaped the body of the T-Rex for giant bipedal life. Fact 48. The T-Rex may have been more common than scientists once thought. For many years, scientists believed the Tyrannosaurus Rex may have been extremely rare during its lifetime. However, newer studies suggest the species may actually have existed in surprisingly large numbers across late Cretaceous North America. Researchers estimate dinosaur populations using ecological models, fossil discoveries, growth rates, and predator-prey relationships. One major scientific study attempted to calculate how many T-Rexes may have lived over the entire existence of the species. The results suggested billions of individual T-Rexes could potentially have existed across millions of years. This does not mean billions lived simultaneously. At any given moment, the actual population likely remained relatively small because large predators require huge territories. Still, across long evolutionary timescales, the total number becomes enormous. The fossil record only preserves a tiny fraction of animals that ever lived. Most bodies decay completely without fossilization. Scientists estimate perhaps only one in many millions of T-Rexes eventually became fossilized and discovered. The fact that researchers already uncovered numerous skeletons suggests the species may have been ecologically successful and widespread. The T-Rex occupied the apex predator role in western North America near the end of the Cretaceous period. Large herbivore populations would support a stable predator presence across many ecosystems. Juveniles and adults likely occupied somewhat different ecological niches, increasing survival opportunities within the species. The rapid growth rate of the T-Rex may also contribute to population success. Animals reaching maturity relatively quickly can reproduce more effectively. Still, life remained dangerous. Juvenile mortality rates were probably high because young dinosaurs faced predation, disease, and environmental hazards. Only a fraction of hatchlings likely survived to adulthood. Scientists continue refining population estimates as more fossils are discovered. Advanced computer modeling now allows researchers to simulate ancient ecosystems more accurately. The idea that billions of T-Rexes may have lived throughout history changes perspective dramatically. The few skeletons displayed in museums represent only microscopic glimpses of a once thriving predator species. The world of the T-Rex was far larger and more populated than the fossil record alone initially suggests. Fact 49. The T-Rex probably experienced competition from other predators. Although the Tyrannosaurus Rex dominated its ecosystem, it was not completely alone among predators. Smaller carnivorous dinosaurs and other dangerous animals also existed within the late Cretaceous environment. Juvenile T-Rexes themselves may even compete with adults indirectly by targeting different prey. Some smaller theropod dinosaurs hunted fast-moving animals, scavenged carcasses, or occupied specialized ecological roles. Crocodilians also lived alongside the T-Rex in rivers and wetlands. Large crocodile relatives could become dangerous scavengers or opportunistic predators. Competition naturally occurs in every ecosystem. Predators compete for food, territory, carcasses, nesting areas, and survival opportunities. The T-Rex likely dominated most direct confrontations because of its enormous size and bite force. However, smaller predators may avoid conflict by feeding on prey too small for adult T-Rexes to pursue efficiently. Scavenging competition probably occurred frequently. A giant carcass could attract many animals simultaneously. The T-Rex may use intimidation, aggression, or sheer size to control feeding sites. Scientists found evidence that some smaller dinosaurs possessed excellent speed and agility. These traits allowed them to exploit different hunting strategies. Ecological diversity reduces direct competition by allowing species to specialize. The T-Rex focused primarily on large prey and giant carcasses. Other predators may concentrate on small animals, fish, eggs, insects, or juvenile dinosaurs. The ecosystem therefore functioned as a complex food web rather than a single predator dominating every niche. Some paleontologists also suggest giant pterosaurs may occasionally scavenge from carcasses left behind by T-Rexes. Competition could become intense during droughts or environmental stress. Predators often become more aggressive when food resources decline. The T-Rex succeeded because its adaptations gave it major advantages in strength, sensory ability, and feeding power. Still, survival required constant interaction with many other dangerous organisms. The prehistoric world remained highly competitive even for the top predator. Fact 50. The T-Rex continues to change scientific understanding, even today. More than 100 years after its scientific discovery, the Tyrannosaurus Rex continues surprising researchers. Every new fossil, technological advancement, and scientific study reveals additional details about this extraordinary predator. Early scientists once imagined the T-Rex as a slow, tail-dragging reptile. Modern research transformed that image completely. Today, the dinosaur appears as a highly specialized sensory-driven predator with advanced vision, strong hearing, powerful muscles, and complex evolutionary relationships with birds. New discoveries constantly reshape understanding. Further evidence from related dinosaurs challenged traditional ideas about dinosaur appearance. Biomechanical studies refined estimates of movement and bite force. Microscopic analyses revealed growth patterns, diseases, and possible soft tissue preservation. Computer modeling now allows scientists to simulate walking, feeding, and hunting behavior with remarkable detail. Advanced scanning technologies expose internal structures hidden deep inside fossils. Researchers continue debating major questions about metabolism, coloration, behavior, social interaction, and reproduction. The T-Rex remains scientifically exciting precisely because many mysteries still exist. Public fascination also drives ongoing exploration. New fossil discoveries frequently become worldwide news. Museums compete to display important specimens, and paleontologists continue searching North American badlands for additional skeletons. The species also transformed broader understanding of dinosaurs overall. By studying the T-Rex and related theropods, scientists strengthened the evolutionary link between dinosaurs and birds. The image of dinosaurs as dull, oversized reptiles largely disappeared because of discoveries connected to species like the T-Rex. Young generations continue growing up fascinated by the predator through documentaries, movies, books, games, and museum exhibits. Few extinct animals maintain such strong influence across both science and popular culture. The T-Rex, therefore, became more than just a fossil species. It evolved into one of the most important symbols of prehistoric life and scientific discovery. Even now, hidden beneath ancient rocks, new fossils may still wait to completely change what humanity thinks it knows about the Tyrannosaurus Rex. The story of the T-Rex is therefore still unfinished. Every discovery brings scientists one step closer to understanding how this legendary predator truly lived within the ancient world. Fact 51. The T-Rex probably had extremely powerful neck bite control. The Tyrannosaurus Rex did not simply possess a strong bite. It also likely possessed remarkable control over how that bite was delivered. Scientists studying the skull, neck, and jaw joints discovered that the dinosaur could apply force with impressive precision. This mattered greatly because attacking prey required more than raw power alone. The T-Rex needed to aim accurately, adjust head movement during struggles, and maintain control while tearing flesh. The giant neck muscles played a critical role in stabilizing the skull. Without proper control, the enormous bite force could actually destabilize the animal itself during feeding or hunting. The reinforced neck, vertebrae, and powerful muscles allowed the dinosaur to direct force efficiently. Some paleontologists compare this system to industrial machinery, where stabilization becomes just as important as strength. The T-Rex may have delivered different types of bites, depending on the situation. A quick warning bite toward a rival would differ from a crushing, killing bite against prey. The animal likely adjusted pressure and angle dynamically. Modern crocodiles and large predatory mammals show similar bite variation. Researchers examining wear marks on fossil teeth found evidence suggesting repeated, controlled feeding motions. The T-Rex probably did not simply clamp randomly onto carcasses. Instead, it may have used practiced head and jaw movements to maximize feeding efficiency. The flexibility of the neck also allowed the predator to reposition the skull rapidly. This would become especially useful when prey struggled violently. Strong coordination between eyesight, neck muscles, and jaw control likely made the T-Rex a far more sophisticated hunter than older depictions suggested. The dinosaur was not just a giant mouth on legs. It was a highly integrated predatory system refined through millions of years of evolution. Fact 52. The T-Rex probably grew faster than most modern reptiles. The growth speed of the Tyrannosaurus Rex was extraordinary. Most modern reptiles grow relatively slowly over long periods. The T-Rex, however, appears to have developed much more rapidly. Bone studies reveal periods of explosive growth during adolescence. Some researchers estimate teenage T-Rexes gained several pounds every single day. This rapid development allowed the animal to reach gigantic adult size within only a few decades. Scientists determine growth rates by studying microscopic rings preserved inside fossil bones. These growth rings function somewhat similarly to tree rings. Wide ring spacing indicates periods of fast development. The T-Rex consistently shows evidence of accelerated growth during middle life stages. This pattern resembles growth in birds and mammals more closely than modern reptiles. The rapid growth also supports theories suggesting elevated metabolism. Animals growing quickly generally require efficient energy processing and high food intake. The T-Rex therefore likely consumed enormous amounts of nutrients during adolescence. Its body transformed dramatically during these years. Juveniles with slim, fast bodies gradually became heavily built adults with giant skulls and crushing bite force. The growth process likely required major hormonal and physiological changes. Scientists compare these developmental transitions to modern animals undergoing dramatic maturation phases. Rapid growth also provided survival advantages. Young predators reaching large size quickly become less vulnerable to threats. A fast-growing T-Rex would move rapidly through dangerous juvenile stages toward dominance. The discovery of accelerated growth changed how scientists viewed dinosaurs overall. For decades, dinosaurs were imagined as sluggish, cold-blooded reptiles. The T-Rex growth evidence instead suggests highly active biology more comparable to birds. The species evolved into one of the fastest-growing giant predators in Earth's history. Fact 53. The T-Rex had a highly specialized sense of balance. Maintaining balance as a giant two-legged predator required extraordinary coordination. The Tyrannosaurus Rex evolved specialized structures helping stabilize its enormous body during movement. Scientists studying the inner ear found enlarged semicircular canals associated with balance and head positioning. These structures help animals coordinate movement and maintain orientation. Predators especially benefit from advanced balance systems because hunting involves rapid adjustments and precise body control. The T-Rex needed to stabilize a massive skull while moving across uneven terrain. Its long tail acted as a dynamic counterbalance. Muscles connecting the tail to the legs helped coordinate movement and maintain posture. The center of gravity sat near the hips, improving overall stability. Researchers using biomechanical models discovered the T-Rex body was surprisingly well balanced, despite its enormous head. The feet also contributed significantly. Wide weight-bearing toes spread pressure efficiently and prevented instability. Modern birds inherited many balance-related features from theropod ancestors. Large birds today display impressive coordination while walking and running on two legs. The T-Rex represented an extreme version of this evolutionary design. Balance became especially important during feeding. Violent head movements while tearing flesh could easily destabilize the body without proper muscular coordination. The strong legs and tail compensated for these forces. Researchers believe the T-Rex moved with deliberate, controlled motion rather than awkward clumsiness. The animal likely adjusted posture constantly to maintain equilibrium. This specialized balance system allowed the T-Rex to support one of the largest heads ever carried by a land predator. Without such coordination, the giant body plan would become mechanically inefficient. Fact 54. The T-Rex may have recognized members of its own species. Although direct evidence remains limited, some scientists believe the Tyrannosaurus Rex may have possessed the ability to recognize other T-Rexes individually, or at least identify members of its species. Modern predators frequently distinguish rivals, mates, offspring, and territory intruders. Recognition behavior provides important survival advantages. The T-Rex possessed advanced sensory systems including strong smell, hearing, and vision. These senses could help identify other individuals through sound, appearance, or scent. Some paleontologists speculate that chemical communication may have existed. Modern reptiles and mammals often use scent cues for territory marking and mating. Visual displays may also contribute. Body posture, scars, coloration, or feather patterns could help distinguish individuals. The large brain regions associated with sensory processing suggest the T-Rex interpreted complex environmental information. Interactions between adults probably included competition over territory, food, or mating opportunities. Recognizing rivals would reduce unnecessary conflict. Young T-Rexes may also need to identify adults either as threats or potential parents. Some scientists debate whether tyrannosaurs displayed limited parental care. If so, recognition abilities become even more important. Modern birds, the direct descendants of theropod dinosaurs, often show highly developed social recognition. While the T-Rex likely was not socially complex like wolves or primates, it may still possess more behavioral sophistication than traditionally imagined. The possibility of species recognition highlights how dinosaurs increasingly appear as dynamic living animals rather than simplistic monsters. Their behavior may include communication, signaling, and environmental interpretation far beyond earlier assumptions. Fact 55. The T-Rex probably faced extreme weather conditions. Life during the Late Cretaceous was not constantly calm and stable. The Tyrannosaurus Rex likely experienced storms, floods, droughts, seasonal temperature changes, and other environmental extremes. Scientists studying ancient sediments discovered evidence of rapidly shifting river systems and catastrophic flooding events. Massive storms may periodically reshape entire landscapes. Floodwaters could uproot forests, bury animals, and create dangerous terrain. Many fossil beds themselves probably formed during such catastrophic events. Drought periods may become equally dangerous. Reduced water availability would stress plant life and force herbivores to migrate or concentrate near remaining rivers. Predators like the T-Rex would follow these prey movements. The climate of the Late Cretaceous remained warmer overall than modern Earth, but weather systems still produced environmental instability. Lightning storms, heavy rainfall, and strong winds likely occurred regularly. The T-Rex therefore survived within constantly changing ecosystems. Large body size may help resist some environmental challenges. However, giant animals also require enormous food and water resources. Environmental disruptions could therefore become serious survival threats. The ability to adapt behaviorally to changing conditions likely contributed to the success of the species. The T-Rex was not only battling prey and rivals, it was also enduring the unpredictable forces of prehistoric nature itself. Fact 56. The T-Rex probably had extremely sharp hearing for deep sounds. The Tyrannosaurus Rex likely possessed hearing abilities especially tuned toward low-frequency sounds. Scientists studying the inner ear structures of fossil skulls discovered evidence suggesting the dinosaur could detect deep vibrations and low rumbling noises extremely well. Low-frequency sound travels farther than high-pitched sound. It can move through forests, around obstacles, and across large distances more effectively. Many giant modern animals use low-frequency communication today. Elephants produce deep rumbles that travel miles. Crocodiles create powerful vibrations through water and air. The T-Rex may have used similar sound ranges. This hearing specialization would provide major survival advantages. The dinosaur could potentially detect distant prey movement, approaching rivals, storms, or environmental disturbances before seeing them directly. Large herbivorous dinosaurs moving through forests likely produced deep ground vibrations and heavy noises. The T-Rex may have sensed these movements from significant distances. Researchers compare the hearing anatomy of the T-Rex with birds and crocodilians because both groups share evolutionary connections with dinosaurs. The inner ear structure strongly suggests sensitivity to deeper frequencies rather than extremely high-pitched sounds. This does not necessarily mean the T-Rex ignored other sound ranges. However, low-frequency specialization likely formed a major part of its sensory toolkit. The ability to hear deep sounds could also improve communication between individuals. If T-Rexes produced booming calls or vibrations, those sounds might carry across large territories. Scientists continue debating exactly what noises the T-Rex made. Still, the evidence increasingly points toward deep, resonant vocalizations rather than dramatic movie-style roaring. The hearing system also worked together with balance mechanisms inside the inner ear. Predators require strong coordination between hearing, movement, and environmental awareness. The T-Rex therefore appears to have evolved a highly advanced sensory system rather than relying on brute strength alone. Fact 57. The T-Rex probably used energy-efficient walking patterns. Despite its gigantic size, the Tyrannosaurus Rex likely moved in surprisingly energy-efficient ways. Scientists studying biomechanics discovered that large animals often evolve walking patterns, minimizing wasted energy. The T-Rex needed efficiency because carrying several tons of body weight requires enormous muscular effort. The long tail acted as a balancing structure, reducing strain on the torso. Strong leg muscles and stable hips allowed the dinosaur to move with controlled rhythm. Researchers using computer simulations found that the T-Rex probably preferred moderate walking speeds most of the time. Fast sprinting would dramatically increase injury risks. A fall at high speed for such a heavy predator could become catastrophic. Instead, the dinosaur likely relied on endurance, sensory awareness, and ambush tactics. The feet also helped conserve energy. Wide toes distributed pressure evenly across the ground. Soft tissue pads may absorb impact forces during walking. The spine and tail coordinated movement efficiently. Modern birds inherited many movement principles from theropod ancestors. Large flightless birds today use highly efficient walking mechanics. The T-Rex represented a gigantic evolutionary extension of similar two-legged design strategies. Energy efficiency would become especially important while traveling across huge territories. The dinosaur may spend long periods walking between feeding opportunities. Conserving energy improves survival for all large predators. Researchers also study fossil footprints to estimate stride length and movement patterns. These tracks suggest stable, coordinated locomotion rather than awkward stumbling. The T-Rex therefore functioned less like a chaotic movie monster and more like a carefully balanced giant animal optimized for efficient movement. Fact 58. The T-Rex probably experienced long juvenile years. The Tyrannosaurus Rex did not hatch as a giant predator immediately. Like most large animals, it likely spent many years growing through vulnerable juvenile stages. Young T-Rexes looked very different from adults. They possessed slimmer bodies, longer legs, and narrower skulls. Scientists believe juveniles occupied different ecological roles while developing. The early years of life were probably extremely dangerous. Small juvenile dinosaurs faced threats from predators, environmental hazards, disease, and food competition. Only a fraction of hatchlings likely survived long enough to reach adulthood. Researchers studying growth rings inside bones discovered that T-Rexes experienced rapid development during adolescence. However, reaching gigantic adult size still required many years. During these juvenile stages, young T-Rexes may rely more heavily on speed and agility than raw strength. Their lighter bodies likely allowed them to chase smaller prey effectively. This ecological flexibility may reduce competition with adults. The transformation into a full apex predator occurred gradually. As the skull deepened and muscles expanded, hunting strategies probably changed as well. Scientists compare this process to modern predators whose behaviors evolve with age. Juvenile crocodiles, lions, and birds often feed differently from adults. The long developmental period of the T-Rex highlights how complex its life cycle truly was. The species was not born dominant. Instead, individuals needed years of survival, growth, and adaptation before finally reaching the top of the food chain. Fact 59. The T-Rex may have been capable of short, explosive bursts of speed. Although the Tyrannosaurus Rex probably was not a marathon sprinter, scientists believe it may still have been capable of short, powerful bursts of movement. The huge leg muscles and strong tail provided tremendous force generation. Researchers studying biomechanics debate the exact top speed of the T-Rex. Earlier estimates suggested extremely high running speeds, but newer studies became more cautious. The enormous body weight creates major mechanical challenges. Running too fast could place dangerous stress on bones and joints. However, moderate speed does not mean slow. Even a short explosive charge from a predator several tons in weight would become terrifying. The T-Rex likely relied on acceleration over short distances rather than prolonged chases. Ambush attacks, combined with bursts of force, may prove especially effective. Modern large predators often use similar strategies. Lions, crocodiles, and bears rarely maintain maximum speed for long periods. Instead, they depend on timing, surprise, and power. The T-Rex probably behaved similarly. Its binocular vision and strong balance would help coordinate sudden attacks. The tail muscles connecting into the legs likely played major roles during acceleration. Researchers used digital skeletal reconstructions to estimate how muscles distributed force during movement. Most evidence suggests the T-Rex moved more athletically than older sluggish depictions implied. The predator therefore combined immense power with at least moderate mobility. Even without extreme speed, few prey animals would survive a successful close-range attack from the giant predator. Fact 60. The T-Rex represents the final peak of tyrannosaur evolution. The Tyrannosaurus Rex was not the first tyrannosaur. It evolved from a long line of earlier relatives that existed for millions of years before it appeared. Early tyrannosaurs were much smaller animals. Some were only the size of humans. Over time, tyrannosaurs gradually evolved larger bodies, stronger skulls, improved senses, and more specialized predatory adaptations. The T-Rex represents the final and most extreme stage of this evolutionary process. Scientists discovered many tyrannosaur relatives across North America and Asia. Species such as Albertosaurus, Gorgosaurus, Tarbosaurus, and Daspletosaurus reveal how the group changed over time. Some close relatives already possessed strong jaws and large heads. However, the T-Rex pushed these features even further. Its bite force became among the strongest ever evolved by a terrestrial predator. Its skull deepened massively. Its senses became highly advanced. The body balanced gigantic size with efficient movement. The T-Rex therefore represents millions of years of evolutionary refinement. Natural selection gradually shaped tyrannosaurs into increasingly specialized apex predators. The extinction event ending the Cretaceous period abruptly stopped this evolutionary line. Without the asteroid impact, tyrannosaurs may potentially continue evolving into even more specialized forms. Instead, the T-Rex became both the peak and the final chapter of giant tyrannosaur evolution. Today, scientists study the T-Rex not only as an individual species, but also as the culmination of one of the most successful predator lineages in dinosaur history. Fact 61. The T-Rex probably had excellent coordination between its senses. The Tyrannosaurus Rex did not rely on a single sense while hunting or surviving. Instead, scientists believe it combined smell, hearing, vision, balance, and movement into a highly coordinated sensory system. Its forward-facing eyes provided strong depth perception. Its enlarged olfactory bulbs gave it an excellent sense of smell. Its inner ear structures suggest advanced hearing and balance. Together, these features created one of the most sophisticated predatory systems among known dinosaurs. The T-Rex likely processed environmental information constantly while moving through forests, river valleys, and floodplains. A distant sound, scent trail, or movement could all provide clues about prey, rivals, or danger. The brain regions associated with sensory processing appear relatively advanced compared to many earlier large reptiles. Scientists studying digital brain reconstructions found strong development in areas connected to coordination. This would allow the dinosaur to react efficiently during hunting. For example, the T-Rex could potentially smell prey before seeing it, hear movement through vegetation, then use binocular vision to judge attack distance accurately. Such coordination becomes especially important for a giant predator. Mistimed attacks could result in injury. The dinosaur, therefore, depended heavily on accurate environmental interpretation. Modern predators such as wolves, crocodiles, eagles, and big cats also combine multiple senses while hunting. The T-Rex likely functioned similarly, although on a much larger scale. Its sensory coordination may even help explain its success as an apex predator near the end of the dinosaur age. The more scientists study the skull and brain anatomy, the more the T-Rex appears as an active, highly adapted hunter rather than a primitive reptilian brute. Fact 62. The T-Rex probably lost heat slowly because of its huge size. The gigantic size of the Tyrannosaurus Rex may have helped it maintain relatively stable body temperatures. Large animals naturally gain and lose heat more slowly than small animals because of their volume. Scientists call this phenomenon gigantothermy. Even if the T-Rex was not fully warm-blooded like modern mammals, its massive body would still retain heat efficiently. This means adult T-Rexes may remain active for longer periods without rapid temperature changes. Modern giant animals show similar patterns. Large crocodiles, whales, and leatherback sea turtles maintain more stable body temperatures compared to smaller animals. The T-Rex may have benefited from the same principle. The warm climate of the Late Cretaceous also influenced temperature regulation. Without permanent polar ice caps, global temperatures remained generally higher than modern averages. However, large body size can create overheating risks as well. Adult T-Rexes likely needed ways to avoid excessive heat buildup. Resting during the hottest parts of the day, staying near water, or limiting prolonged high-speed activity could help regulate body temperature. Juveniles may face different challenges because smaller bodies lose heat faster. This difference supports the idea that younger T-Rexes may possess more feather-like insulation than adults. The debate about dinosaur metabolism remains one of the biggest questions in paleontology. Still, most scientists agree the enormous size of the T-Rex significantly influenced how it handled heat and energy. Its body functioned differently from both small reptiles and modern mammals. The T-Rex, therefore, may represent a unique biological strategy unlike any living animal today. Fact 63. The T-Rex probably experienced fierce competition during mating seasons. Although direct evidence remains limited, scientists believe adult Tyrannosaurus Rexes likely competed intensely for mating opportunities. In modern animals, large predators frequently engage in displays, combat, or territorial behavior during breeding periods. The T-Rex probably behaved similarly. Fossil skulls containing bite marks and healed injuries may provide clues about these confrontations. Some wounds appear concentrated around the face and jaws, areas commonly targeted during dominance disputes in modern animals. The giant size and strength of adult T-Rexes would make such confrontations extremely dangerous. Even minor injuries could become serious because of infection risks. Scientists therefore suspect intimidation displays may often occur before physical combat. Posture, vocalizations, head movements, and visual displays could help establish dominance. The dinosaur may also use scent cues or territory marking to communicate reproductive status. Modern birds and reptiles display a wide variety of mating behaviors. Since birds evolved from theropod dinosaurs, some paleontologists believe dinosaurs may exhibit more complex reproductive behavior than traditionally imagined. The exact appearance differences between male and female T-Rexes remain uncertain. Some researchers proposed slight differences in body size or bone structure, but clear evidence remains debated. Reproduction likely required enormous energy investment. Females producing large eggs would need substantial nutritional resources. Seasonal environmental conditions may also influence breeding timing. Although many mysteries remain, the mating behavior of the T-Rex was probably far more dynamic and competitive than older, simplistic depictions suggested. Fact 64. The T-Rex may have used rivers as natural travel routes. The landscapes inhabited by the Tyrannosaurus Rex contained extensive river systems, wetlands, and floodplains. Scientists believe these river corridors may serve as important travel routes for many prehistoric animals. Moving along rivers provides several advantages. Water sources attract prey animals regularly. Vegetation often grows densely near rivers, supporting herbivore populations. Riverbanks can also create easier movement paths compared to dense forests. The T-Rex likely encountered many prey opportunities near these environments. Seasonal flooding constantly reshaped the landscape, creating changing channels, muddy plains, and temporary lakes. Predators, capable of adapting to these shifting environments, would gain survival advantages. The T-Rex may also use rivers for cooling during hot periods. Large modern predators frequently remain close to water for both hydration and temperature regulation. Scientists studying sedimentary rocks discovered many T-Rex fossils within ancient river deposits. This suggests the species spent considerable time near waterways. Flood events probably also contributed to fossil preservation by rapidly burying skeletons in sediment. The relationship between the T-Rex and river ecosystems therefore shaped hunting, movement, and fossilization alike. The predator did not exist within isolated forests alone. It moved through interconnected landscapes, constantly influenced by water and changing environmental conditions. Fact 65. The T-Rex probably faced danger, even as an apex predator. Being the top predator in an ecosystem does not guarantee safety. The Tyrannosaurus Rex still faced many dangers throughout life. Large prey animals such as Triceratops possessed powerful defensive weapons capable of inflicting severe injuries. Broken bones, infections, and bite wounds preserved in fossils prove the T-Rex frequently experienced trauma. Young T-Rexes faced even greater risks. Juveniles likely remained vulnerable to predators, starvation, environmental disasters, and disease. Only a fraction probably survived long enough to reach adulthood. Natural disasters such as floods, droughts, storms, and wildfires also threatened survival. Seasonal food shortages could create intense competition between predators. Even adult T-Rexes may occasionally fight one another over territory, carcasses, or mating opportunities. These confrontations could become deadly. Disease represented another major threat. Some fossils preserve signs of chronic infections and bone damage. Parasites may also affect prehistoric animals just as they affect modern ecosystems. The T-Rex therefore lived within a harsh, dangerous world despite its incredible strength. Its dominance came not from invulnerability but from the ability to survive repeated challenges over time. The fossil evidence reveals a predator constantly struggling against injuries, environmental stress, and competition. This makes the real T-Rex even more impressive. It was not a mythical, unstoppable monster. It was a living animal surviving through resilience, adaptation, and evolutionary specialization within one of the most competitive ecosystems in Earth's history. Fact 66. The T-Rex likely had one of the most powerful necks among predatory dinosaurs. The neck of the Tyrannosaurus Rex was an engineering masterpiece of prehistoric evolution. Supporting a skull over 5 feet long required extraordinary muscular strength and skeletal reinforcement. Scientists studying the neck vertebrae discovered huge attachment points for muscles connecting the head, shoulders, and torso. These muscles allowed the T-Rex to move its enormous skull with impressive control and force. The neck likely played major roles during feeding. Instead of simply biting and chewing like mammals, the T-Rex probably used violent pulling motions to tear flesh from prey. The powerful neck muscles would yank the head backward and sideways while the jaws remained clamped onto meat. This feeding style allowed the dinosaur to remove huge chunks rapidly. The neck also stabilized the head during movement. Each step generated vibrations throughout the body. Without strong stabilization, the massive skull would swing inefficiently and waste energy. The vertebrae themselves balanced flexibility with strength. The T-Rex needed enough movement range to track prey while maintaining structural durability. Researchers using biomechanical models found the neck could likely absorb substantial stress during hunting and feeding. The neck muscles may even assist in generating additional bite force by driving the head downward during attacks. Modern crocodiles and birds provide useful comparisons because both groups share evolutionary relationships with theropod dinosaurs. Large birds, such as ostriches, also rely heavily on neck flexibility for feeding and environmental awareness. The T-Rex represented an extreme, gigantic version of similar anatomical principles. Some fossils preserve signs of neck injuries and healed damage. This indicates the region endured heavy physical strain throughout life. Without such a powerful neck, the giant skull and bite force of the T-Rex would become far less effective. The neck therefore formed a crucial link between sensory systems, feeding behavior, and predatory power. Fact 67. The T-Rex probably had excellent long-distance vision. The Tyrannosaurus Rex likely possessed outstanding long-distance vision. Its large, forward-facing eyes and advanced visual processing abilities suggest the dinosaur could detect movement and shapes from impressive distances. Scientists studying the skull found that the eye sockets were proportionally large. Large eyes generally gather more light and improve image quality. Researchers comparing T-Rex vision with modern animals estimate the dinosaur may have possessed sharper eyesight than many living predators. Strong binocular vision also improved depth perception. The T-Rex needed accurate distance judgment during hunting. Detecting prey early across open terrain would provide major advantages. The late Cretaceous environment included floodplains, river systems, forests, and open areas. Long-distance vision would help the predator scan for prey, rivals, scavenging opportunities, or environmental dangers. The brain regions associated with sight also appear well developed in endocast studies. This suggests visual information played an important role in behavior. The famous movie myth claiming the T-Rex could only see movement has no scientific basis. In reality, the dinosaur almost certainly detected stationary objects effectively. The myth became popular mainly through fictional storytelling. Scientists now view the T-Rex as one of the most visually capable large predators of the dinosaur world. Its eyesight likely worked together with smell and hearing to create an integrated hunting system. The predator may even function effectively during lower light conditions, such as dawn or dusk, because of the large eye size. Strong vision helped transform the T-Rex into a highly efficient apex predator rather than a slow, clumsy reptile. Fact 68. The T-Rex may have produced deep vibrations felt through the ground. Some scientists speculate the Tyrannosaurus Rex may have communicated using low-frequency sounds and vibrations capable of traveling through the ground. Modern elephants produce infrasound vibrations, detectable across long distances. Crocodiles also create low-resonant sounds, felt physically as much as heard. Because the T-Rex possessed large hearing structures adapted for low-frequency sound, similar communication methods may have existed. Deep vibrations would provide advantages in dense forests and across large territories. Low-frequency signals travel farther than high-pitched sounds and penetrate obstacles more effectively. A giant predator, several tons in weight, already generated heavy ground vibrations while walking. Purposeful vocal vibrations could potentially carry even farther. Scientists cannot prove exactly what noises the T-Rex made, because soft vocal tissues rarely fossilize. However, comparisons with birds and crocodilians provide important clues. The T-Rex may have produced booming calls, deep rumbles, hisses, or resonant chest vibrations, rather than dramatic movie-style roaring. These sounds could serve multiple purposes, including territorial displays, mating communication, intimidation, or contact between individuals. The ability to sense ground vibrations would also help detect prey movement. Large herbivorous dinosaurs moving across floodplains likely created substantial vibrations. The T-Rex may therefore use both hearing and physical vibration sensing to monitor its surroundings. The idea of giant predators communicating through earth-shaking low-frequency sounds makes prehistoric ecosystems feel even more alive and dynamic. The real soundscape of the dinosaur age was probably far stranger and more complex than modern humans can fully imagine. Fact 69. The T-Rex probably experienced rapid tooth wear. The feeding behavior of the Tyrannosaurus Rex placed enormous stress on its teeth. Unlike many predators that mainly sliced soft flesh, the T-Rex frequently bit through bone. This behavior caused significant tooth wear over time. Scientists studying fossilized teeth discovered scratches, fractures, and worn serrations caused by repeated feeding stress. The banana-shaped teeth were extremely durable, but even strong teeth gradually deteriorate under constant crushing force. The T-Rex solved this problem through continuous tooth replacement. New teeth constantly developed beneath old ones inside the jaw. When a tooth broke or wore down severely, another replacement eventually emerged. Researchers estimate the dinosaur replaced teeth regularly throughout life. This system allowed the predator to maintain effective feeding ability despite constant damage. The wear patterns also provide clues about feeding style. Deep scratches and broken tips suggest violent contact with bone. Some prey fossils even contain embedded T-Rex tooth fragments, proving teeth occasionally snapped during attacks. Modern crocodiles show somewhat similar tooth replacement systems, although the T-Rex bite force far exceeded most crocodilians. The constant cycle of wear and replacement demonstrates how specialized the feeding behavior became. The T-Rex evolved jaws capable of exploiting carcasses more completely than many other predators. Bone marrow contains valuable nutrients and fat. Crushing skeletons therefore provided additional energy. The rapid tooth wear was essentially the cost of one of the most powerful feeding systems ever evolved on land.